All right, so what you're about to watch is a JavaScript course that I actually recorded a few months ago that was meant to be part of a paid product, but I decided to not actually release that product, but I was just sort of sitting on this course, so I decided that we'd put it up here for free on YouTube. So this is a complete beginner JavaScript course. And of course, if you want to follow along, there's going to be a few different things you need. So first of all, I'm using Visual Studio Code as my code editor throughout this course. So you can get that here at code.visualstudio.com, and there'll be links at the top of the description. There'll be a download link for Mac, or if you're in Windows, it'll say for Windows. Same thing for Linux. And then I use two different extensions. So these are extensions for Visual Studio Code. So after you install VS Code, you can install these two extensions. First is going to be Code Runner. This is just how I run the code throughout the course. And then we'll also have Live Server. And we're not going to be using this one until the second half of the course, but we do use this for running our web pages. Additionally, you'll notice that throughout the course, you're going to see a watermark for dev.fyi. This was where I was planning on actually releasing this course, but I decided I didn't want to charge for it, so it's going on YouTube. But there's going to be some other cool stuff coming to this dev.fyi domain. So if you're interested in that, you can go to dev.fyi and you'll see there's this coming soon, and you can enter an email address and you'll be just notified whenever we are actually launching things. It's not going to be for a while, but there will be things coming to this domain fairly soon that I think a lot of you might be interested in. All right, so now we're here in the code editor, and the first thing I want to do is to create our first program. And a program, all that means is simply a set of instructions for the computer. And those instructions come in the form of code. And this code that we're writing, of course, is going to be JavaScript code. So for this first program, what we're going to do is create a Hello World program. This is a sort of classic program you do as the first program in most programming languages. And all it's going to do is to output the text Hello World. So the way we can do this is by typing console.log, and you'll want to just copy this exactly as I do for now. Don't worry too much about all of the exact syntax, except for just making sure you have it exactly as I type it, and we'll go back and explain what all of this means in a bit. But for now, just type console.log, and then open up parentheses, and inside of those parentheses, you can open up quotation marks. Inside of the quotes, we'll put our text, so hello world, and then after the entire thing, we'll add a semicolon. So what this does is it says go to the console, which is essentially our output in JavaScript, and log to that console. So print to the console whatever is inside of these parentheses. And what's inside of those parentheses is this quotation, and quotation marks actually denote what we call a string. So essentially just text. So we have the text of hello world, which is going to go to that console. And then we have a semicolon at the end, which is sort of like what the period is in English. It's just the end of a sentence. A semicolon is the end of a line of code. So this just denotes the end of this line. So we can run this code by right-clicking and clicking Run Code, or using the keyboard shortcut, which on a Mac is going to be Command-R, and on a PC it'll be Control-R. So I'll do that now, and we can see we now get the output of Hello World down here. And that is our first program. But again, don't worry too much about all of these small details of this. We'll learn a lot more about what all of this means throughout the course. So for example, what exactly is this period doing? What do the parentheses mean? What exactly is that semicolon actually doing? All of these things we'll be answering throughout the course, so don't worry about it too much, but this is our first Hello World JavaScript program. All right, so now that we've made our first program, what I want to look into next is something known as a variable. And variables in code work very similar to variables in basic mathematics. That is that we choose some name. So for example, in math, we oftentimes use X and Y, but in code, we'll use sort of more descriptive names. But anyways, we choose some name, and then we assign it some value. So to do this in JavaScript, we're going to use the let keyword. So we say let, and then we give it some name. So for example, let's say let text, and then we use the equal sign. This is known as the assignment operator. And then after the equal sign, we put whatever the value is. So for example, I can do this same hello world value just like this. And now the value of text is hello world. So for example, if I removed this text here and replaced it with the word text not in quotation marks, this now refers to this variable. So now we're going to be printing out hello world. So if I run this again, we can see we still print hello world. And because we use let, and we'll see other ways to actually declare variables later, but with let, which is sort of the most basic form of a variable, we can actually reassign this as well. So for example, if we wanted to change text to be something else, so let's come down here below the console log, and let's say text is now going to equal JavaScript. So now we set text to be hello world, and then we log out that text, which is hello world. But then we update the text to be JavaScript. And what I'm going to do is now after this update, we're going to log the text again. So now you can see, first we log hello world. So that's coming from here. And then second, we log the second text, which is now JavaScript. And you'll notice I'm not using the let keyword again here. So we use let to create a new variable, but then if we ever want to update that variable, we no longer use let. So if I even tried to do this again, you'd see it underlines it in red. And if I ran this, we would actually just get an error message because you cannot create the same variable twice, but you can override that variable. That said, if we did want to create both of these and have them both exist, we could create a completely different second variable. So for example, let's say let, and instead of text, we'll give this a more descriptive name, such as programming language is now equal to JavaScript. And we could use this in the second console log. And now when we log this out, we can see we get hello world and JavaScript. And even if I move this one below the let programming language line, we'd still get the same thing because text in this case is never being overridden. It is still hello world and programming language is JavaScript. So these variables are unrelated to each other. Next, I want to look a little bit more deeply into what exactly these strings are. So strings are a primitive type in JavaScript. Essentially, this just means that they're one of the basic building block types that we use within JavaScript, and we'll be seeing some more primitives throughout the next few videos. But with strings, there's actually a few different ways we can declare them and a few ways we can use them, so I want to look at that in this video. So the first thing I want to note is that there's actually a few ways to declare a string. So one way we've seen is using double quotes like this. So we have double quotes and anything inside of them is the string. But we can also use single quotes. So if instead of the double quotation, I used single quotes, this would do the exact same thing. And which one you choose to use is mostly just personal preference. Personally, I tend to use single quotes, but either way is fine. I just say try to be consistent across your work. Now, there's one tiny difference, and that is, what if, say, I wanted an actual quotation mark here in the middle of my string? Well, this is going to work because the string is being created using single quotes, so the double quote doesn't mean anything, so I can have that inside of my string. We can see if I run this, we get that here. But if my string was actually using double quotes to create the string, well, then now we have this issue of JavaScript thinks the string ends here. And then it's like, what is all this stuff after the string? So that doesn't really work. So if you do need double quotes or single quotes within your string, generally we just use the other option to create the string. But there is one other way we can do this, and that's known as an escape character. So before this quote that we want to say, hey, JavaScript, this is not a quote meaning the end of the string, it's just a quote that's part of the string, we can add a backslash here, and that just says, hey, this next character, escape it, meaning just treat it as part of the string. And if I run this, we can see we now get hello world with that quote character there. Now, there is finally one other way that we can create a string, or one other primary way, and that is using backticks. So instead of the quotation marks, I will use backticks now. And this is known actually as a template literal. So if I just use backticks, it again is going to create a string, and it's essentially the same thing we've seen. But there is one thing special about using backticks, and that's that we can actually embed other code within the string. So for example, let's say I had another string. So let's say let name equal, and I'll just have my name here. And maybe I wanted it to say, instead of hello world, I wanted it to be hello and then whatever that name is. Well, the way we can do this is using these backticks. So the template literal, we can do a $sign and then curly braces. So we're going to open and close curly braces, and inside of these curly braces, we can add any JavaScript code, and it's going to execute that code and just place it in the string. So in this case, let's just say name. So what it's going to do is it's going to say, okay, here I have the $sign curly brace syntax. So whatever is inside of here, in this case, it is the name variable. We're going to replace this entire thing with that. So this is actually going to become the string of hello Connor. That said, there's one other way to do this, and this is sort of a common theme of JavaScript that oftentimes there's lots of ways to do the same thing, and that's going to be something known as concatenation. So let's, instead of using these backticks, let's go back to a standard string. And first of all, you'll see if I run this code as a standard string, we are actually going to output hello and then this $sign name because we are no longer using a template literal. But one thing we can do here is to remove this and instead use the plus sign. So this is the concatenation operator. So we are adding to it another string. And in this case, we're going to add the name string. Now you can see we get hello Connor. Now by doing this, we did remove that exclamation mark. So if we did want it back, we could actually concatenate another string. And this one is going to be that exclamation mark. And now we get hello Connor exclamation mark. Generally speaking, I do tend to prefer using template literals over concatenation because it gets a little bit messier having all of these plus signs, and then you need to be careful to include the empty spaces because if I just had hello plus name, we would get hello Connor as one word. So you have to be very careful when you use concatenation to be adding all of the correct spaces and not to forget anything and to have all of the plus signs. So just in general, I tend to prefer using template literals, but either way is a valid way to sort of combine strings together. Now, of course, strings are not the only primitive type in JavaScript, and one of the most important ones is going to be the number type. So numbers work a lot how you would expect them to. So for example, I can say let num equals, let's say 10, and then we could do console.log our num, and this is going to log out the number 10. And then of course we can do different types of arithmetic with these numbers. So I could say maybe log out number plus 5 and we'd get 15. Now it's worth noting that this plus sign is sort of an overloaded operator in that it is both the concatenation operator with strings as well as it is going to be the addition operator when we use it with numbers. We could also do minus, so number minus 5 is going to now be 5. We can do an asterisk for multiplication, so number times 5 is going to be 50, and we can use a / for division, so number divided by 5 is going to be 2. It's also worth noting that in JavaScript, there's not really a distinction between a floating point or decimal number and an integer. So in some languages, these are sort of completely different types. In JavaScript, this is not the case. We just have a single number type. So for example, if I did number divided by 4 instead, this is going to result in 2.5. So we do get a decimal here. And these decimals are what's known as floating point decimals. And all that's really important to know about this is simply that these are decimals. However, they're not going to be perfectly precise all of the time. And this comes down to essentially the way that numbers are stored internally in computers. There's sort of a limit to how many different numbers we can actually store. So there's going to, at times, be some imprecision. So a very famous example of this is if you do 0.1 plus 0.2, you would expect the result would be 0.3. But actually the result is 0.3, a bunch of zeros, and then a 4, which can cause some issues. So just know if you're using these decimals or floating point numbers that oftentimes you might run into these small imprecisions. Now, in addition to these sort of standard arithmetic operators, there's also a few other ones that are included in JavaScript that make our lives very easy. So for example, let's remove this and go back to num. And the next one I want to show is known as the remainder operator. Sometimes you'll see this called a modulo operator, but really it is a remainder. So this is going to be the % and then some other number. So for example, if we do 2, what it's doing is essentially 10 divided by 2. So num is still 10, and we divide by 2, and we take the remainder. Well, 10 divided by 2 is 5, so there's no remainder, so this is going to be 0. However, if, say, we did 3, well, 10 divided by 3 would be 3, 6, 9, and then we have 1 remaining, so the remainder is 1. We can also use exponents, so the way we can do exponents is with 2 multiplication signs, so this is going to be the base, and this is going to be the power. So this is going to be 10 to the 3rd power, and we get 1000. It's also worth noting that we can use negative numbers here as well. So we could say 10 raised to the negative 3rd power, and that's going to give us 0.001. Finally, I wanted to show a few assignment operators, so similar to the equal sign we used here to create a variable, that we can use to sort of change numbers. So I'm going to remove this exponentiation, and let's come up here and let's say num plus equals 5. So what this does is it's essentially the equivalent of saying num is equal to num plus 5. So this is going to add 5 to this number, and then it is going to save it. So it is essentially the same thing as adding and assigning at the same time. So now num is going to be 15. We also have the same thing with minus equals. So num minus equals 5 is going to subtract 5 from this value and save it in the number variable. So now we end up with 5 because 10 minus 5 is 5. And we can do this with lots of different operators. So for example, we could do times equals 5 and we get 50. But the most common is of course going to be plus equals and minus equals. And this is even so common that oftentimes we're just incrementing values, so plus equals 1, that they created a special syntax just for this. So we can also do num plus plus, and this is the increment operator. So all it's going to do is it's going to add 1 to our number and save it in that variable. So now num is 11. We can also do num minus minus, and this is going to subtract 1 from this number. So now we end up with 9. Next, I want to look at another primitive type, and this one is arguably the most simple, and it's known as a Boolean. So a Boolean is simply one of two values, true or false. That's all there is to it. So for example, we can say console.log, and we can use either of these two keywords, true or false. So we can say true, and we can log this, and we get true. We could also say false, log this out, and we get false. So this is useful in a lot of different scenarios, and we'll be seeing it throughout this course for things like checking a condition. So is this thing true or false? Did this thing happen? Did it not happen? Does this user have this setting on or off? Things like that can be very useful with Booleans. They're also going to be the result of a lot of other operations. So for example, let's say let, and I'll just call this val, equal, and let's say, for example, 5 plus 5, and then we can use the triple equal sign, which is the strict equality operator. We'll see more about this in a bit, but we can say 10. So essentially what this is in val, we are storing the result of this. And what this does is it's first going to say add 5 and 5, that gives us 10. And this is checking, is the left-hand side and the right-hand side the same? So val is going to be, is this the same as this? And of course they are, so if we were to log out val, you'd see we get true. Same thing, of course, if we just had 10 and 10, we'd get true. If say we had 10 and 100 though, we would get false. So don't worry too much about this triple equals strict equality operator. We'll be seeing more of that later on in the course. For now, just know that we have these Boolean values of true and false, and sometimes we'll sort of get them in code by checking if things are the same, things like that, as well as we can hard code them in using those keywords of true and false. Next, I'm going to talk about two more primitive types known as null and undefined, and these are very similar types. Both of them represent sort of the absence of values, but they are a little bit different. So I'll explain the differences in a minute, but first, let's just see how exactly we can get them and use them. So first, let's say maybe I have a name variable, but I'm not actually going to assign it to anything just yet. So all I have is let name, and then let's say console.log name. Well, now name is going to be undefined. So literally this means we have not actually defined what name is. All we did was sort of reserve this name of name. So we have a variable called name, but we haven't assigned it to anything. So it is undefined. We can also actually explicitly set things to undefined if we want, but we don't tend to do that very often. So essentially think of undefined as sort of an absence of any value. And then we also have this value of null. And null in JavaScript actually doesn't tend to come up as often, and it means something very similar. So we can see here we were able to log out null. And sort of the difference between null and undefined is that undefined is this absence of value, typically when there just hasn't been a value created there yet. So like the example of having let name without any assignment. Whereas null sort of represents emptiness in a way. So that's sort of the way I like to think about it, is almost like an empty object. And we'll learn more about what exactly object-oriented programming is later on in this course. But null sort of represents nothing, whereas undefined represents this absence of a value because it's not assigned yet. Whereas null is sort of an explicit, I am assigning this as a thing that is just nothingness. And I know that can sound confusing, and oftentimes they get used fairly interchangeably. And in most other programming languages, there's only one of these, is usually just a null value in most languages. So it is a bit confusing and there can be a little bit of overlap, but hopefully that gives you a decent idea of what the difference is between them, and you'll get used to using them a lot over time. And hopefully that becomes more and more clear as to which one's appropriate in which circumstances as you just work with it more. Next, I want to talk about commenting. So commenting is simply a way to add something to the code that's not actually going to change the execution of that code. So most often, this is leaving some note for future developers or even yourself in the future for when you look at some code to explain something about it, but there are other reasons to use commenting on occasion as well. So the way we can comment is simply by adding 2 forward slashes, and then anything after that on the same line is going to be a comment. So no matter what I type here, it's not going to matter. We still have the same output. So this, in this case, creates a number that is 10. We add 1 to the number, and then we console log that number. Even if I put actual code here, so if I said num++ again here, it does not make a difference because this code is commented out, as we say. So meaning that this code is not actually running because it is inside of a comment. In fact, sometimes we use this as a debugging strategy. So if I wasn't sure exactly what's happening with this num++, what I can do is run the code, we get 11, and then try commenting it out to see what we get now. And we get 10 now. So I can see, okay, this line is adding 1 to our output. And this is so common that it's actually built into most code editors. So in VS Code, if you hold down Command in Mac or Control for PC, and then the / button, it's actually going to automatically comment out that line. And if you were to highlight multiple lines and do it, it'll comment out all of those lines. Now, additionally, there is one other way to comment in JavaScript, and that is a multi-line comment. So sometimes you want some very long comment, and the way we can do this is by using a / and then an asterisk. So this opens a multi-line comment. So you can see this code down here is now commented out. So everything after this is commented out until we get to another asterisk and another /. So this ends the comment. So you can see this is no longer commented out because it is after the end of the comment. But if we were to move this down below here, this whole thing would be commented out. So I'll put this back up here and we could add whatever we want here. So we could have some comment, and this can be multiple lines. So with the standard comment syntax of just the 2 /, you only get 1 line. But if you use this syntax here, you get multiple lines for your comment. Okay, so in this video, I want to talk about what we call whitespace. So whitespace simply refers to any space characters, tab characters, and new line characters that are in our code. And the key point of this is that largely speaking, whitespace doesn't actually do anything. There are some exceptions, but most of the time, whitespace is simply there so that the code can be more readable. So as an example, here we have let num equals 5 times 2, then we log out num. So we're going to get 10 because 5 times 2 is 10. But what would happen if, say, we took out the spaces between all of these operators? Well, we still get 10 because those spaces actually don't do anything. They are simply there for the purpose of making the code more readable. Same thing if we added a bunch of more spaces, maybe even some tab characters, we still get 10 because it does not actually make any difference. Now, there are some cases where it will make a difference, so I'll put this back. If, say, we got rid of the space between let and num, well, now we don't actually have the let keyword anymore. We just have let num, and there's no way for JavaScript to know that we intended this to be let and then num, so this is not going to work. So we do need spaces around things like the keywords, but for the most part around operators and things like this, all of the spaces are completely optional and they are just there for the purpose of readability. Same thing with, say, this new line here. We have an empty line here, but it's not actually making a difference. We are simply doing this to make it more readable. In fact, we could put all of our code on the same line and it would still work. It's just going to be harder to read that way, so we typically go to new lines a lot just to space things out. We could even go to new lines within this console log call. So we could do something like this, and that would work. We could move the closing parentheses to a new line. That would still work. We could go way down here and tab this over, and again, it would still work. This code is much harder to read, so I would never write code like this, but it does actually work. So the point is simply that in some occasions, such as the space between let and num, the white space is actually going to matter, but in the vast majority of cases in JavaScript, white space does not actually matter. It is simply there for readability. Okay, so now what I want to talk about in these next few videos is something known as control flow. And all control flow is essentially the order that our code is going to execute in, and we have different ways within our code to control that control flow. So to control the order that our code is going to be executing in, to control what code even executes at all, if code's going to execute multiple times, all of these different things. So for example, here we have this is signed in variable that's set to false. And we can use something known as an if statement to conditionally run code based on some conditions such as is signed in. So based on this Boolean. So let's say if, And then in parentheses, we're going to have a condition. So this is usually going to be a Boolean, for example, is signed in. And if is signed in, we're going to open up these curly braces, and anything inside of the curly braces is going to run if this is true. But if this is not true, then this code will not run. So for example, let's say console.log and simply welcome. And if I run this, nothing is going to happen because is signed in is false. But if we made this true, now we would end up logging out this code. And we can have as much code here as we want. So let's just say welcome to, just so that we can see you can have multiple things inside of this if. But for now, I will delete that. Now, it's worth noting also that the if only applies to what's inside the if, nothing else. So if, say, for example, we had console.log end down here, and we ran this, we'd get welcome and end. And if this was false, we would still get end, because this code has nothing to do with this if whatsoever. But sometimes you do want that to be the case. You want to run code in the case you didn't get into the if. And for that, we have something known as an else. So directly after the if, we can say else, and we don't need parentheses here because there's no condition. This just runs if the other thing didn't happen. So we can open up curly braces here, and we can say console.log, and in this case, let's do something like you need to sign in. Now, if I run this, you can see we get you need to sign in, and we still get end because, again, this has nothing to do with any of this. But if we made this true, we would get welcome and then end, but we don't get into the else because the previous if was true. Now, sometimes you might even want to take this a step further, and we can use something known as an else if to create a chain of conditions. So, for example, let's come down here and let's say else if. For now, I'll just say true, and we can open up more curly braces. And essentially what this is saying is, if this is true, then run this code. Otherwise, check to see if this thing is true. If it is, run this code. Otherwise, just run this code. So for example, in here, we could say console.log, and let's just say else if. And if I run this, you'll see we still get welcome, and we don't get into any of this, even though we have true here because this is an else if, not an if. So we only get into this code if the previous if was false and if this is true. Now, of course, if we didn't have the else here, well, now this is just another if, so we would get into this code because this is now no longer dependent on the previous if. But as an else if, we only get into this block if the previous block was false and if the condition here is true. So, for example, if we made this false instead, then we would in fact get into the else if because this one is false and this one is true. Now, if this was also false, now we get into the else statement because neither the if or the else if before it were true. Now, we can also add another else if we wanted, and we can just create a long chain of these. So let's say else if, and this one, let's just say true for a minute, and we can go like this. And in this one, let's just say console.log first else if, just so that we can keep track of which one is which. We can run this, and you can see we get into first else if. Now, if this was also true, we still only get into this one because this says else if, right? So if nothing before it was true and this is true, do this. But that's not the case because this is currently true. Now, if this was false, we would get into this else if. And if this was true, though, we would not get into either else if because all of these are connected. So essentially, it's just always going to stop at the first true condition. Now, there's one other thing I wanted to show. So let's delete all of these else ifs. And that is that the curly braces are actually optional. So I'm going to remove these curly braces, and we can see this is still going to log out welcome. And if I made this false, we get nothing. However, there is one caveat to this, and this is why I tend to not use this syntax. And that's that when you don't have the curly braces, you only get one statement in the if. So let's come down here and say console.log, and let's just say we had welcome to again. And if I run this, you'll see we get welcome to even though this is false. And even if we tab this over so it looks like it's part of the if, remember whitespace in JavaScript for the most part doesn't do anything. So it doesn't matter. We can run this again and we still get welcome to even though this is false. And even though this looks like it's part of the if, it's not, because the if is only going to have one statement as part of that if block when you don't have the curly braces. So no matter what we do, this is no longer part of this if unless we add the curly braces back in in which case now we can put both of them inside of the if. And just because this can tend to make our code a little bit confusing to read and make it just a tiny bit harder to see what code is versus isn't inside of the if, I do tend to always use the curly braces, but at the end of the day, it's just a stylistic choice, and some people might prefer to use the syntax without those curly braces in some cases. So generally, my recommendation is always use the curly braces unless you're working in a code base where they were already using the style of not using them, in which case you might want to just adhere to the style that that code base is already using. Now I want to talk about a few operators that we tend to use a lot with control flow statements, such as if statements, and the first of these is going to be the equality operators. We've actually seen these before in the video on Booleans. So for example, here we have let val equals 10, 3 equal signs, and then another 10, and then we log out val, and this is going to be true. So what this is known as the strict equality operator. And what it does is it takes the value to the left and the value to the right, and it simply compares them and returns a Boolean. True if they are the same and false if they are different. And how it determines if they are the same is by checking two things. One, do they have the same type? For example, this is a number and this is a number, so they do have the same type. And two, do they have the same value? So this is the value of 10 and this is the value of 10. So again, they have the same value. So type and value are the same, therefore we get true. However, if say the value of this one was different, so let's make this 100, now we get false because 10 is not strictly equal to 100 because 100 has a different value than 10. Additionally, if they were both 10, but say this 10 was a string, we would again get false because they do sort of have the same value in both representing 10, but they have different types. One is a string and one is a number. And we can use these in lots of places. So for example, I could put this directly in the console log and we'd get false like that. But we can also use them in if statements. So for example, we can have maybe let val equals 10, and maybe what we want to do is say if val is strictly equal to 10, then we want to do something. So maybe now we want to console.log out it was 10, and we can run this and we can see we get it was 10, but if val was anything else, so maybe just 1, we would not log out anything. Now, in addition to the strict equality operator, we also have the exact opposite operator known as the strict inequality operator. So this is going to look the exact same, but instead of 3 equal signs, we have an exclamation mark and then 2 equal signs. So the exclamation mark replaces the first equal sign. Now this does the same thing, but opposite. So where strict equality would return true, this returns false. And where strict equality would return false, this returns true. So in this case, this checks, is val not strictly equal to 10? And val right now is 1, so let's say it was not 10, and we get it was not 10. But if this was, say, 10, then we don't log out anything because now it actually was 10. And same thing if we had the string of 10, we get it was not 10 because even though these sort of have the same value, they have different types. Now, there is another form of equality operator known as the loose equality operator sometimes, or just the standard equality operator. And this is going to have one less equal sign. So in this case, I'm just going to remove the exclamation mark. And now we can say it was 10 again. And this is going to work the same way, except for the fact that the loose equality operator does not care about the type. And if there are two different types, it's going to do its best to still compare the values to see if they are the same. And we're not going to go into all the details of what exactly the rules are of how it does that comparison, but generally speaking, if they have different types but still the same value, it will still say they were the same. So in this case, we get it was 10, because val, even though it's a string, it still is 10, and this is the number 10, so it's going to do its best to say, okay, these are both 10, so it was 10. But if, say, this was the string of 100, we would get nothing. But if they were the exact same, we would still get it was 10, because again, they are both 10. And same thing if, say, we changed this one to be the string of 10, we still get 10, because again, it thinks of them as sort of the same. And of course, there's an inverse operator for this as well. So there's a loose inequality operator. So we can replace the first equal sign with an exclamation mark. And now we get the opposite. So now nothing is going to happen here. If, say, we made this the string of 100, though, we would get it was, and let's put not here, and now it's 100, so we can say it was not 100 because these are different. Same thing if this was a number because they're not the same, but then if we made these actually be the same, we would not log out anything because, this is not giving us a value of true. Now, almost 100% of the time, we don't want to actually use these loose equality operators just because these rules are a little bit finicky and they can lead to bugs when something doesn't do exactly what you expect it to do. So because of that, we almost always want to use strict equality, except there is one sort of exception to this where it's generally considered okay to use loose equality, and many people, myself included, actually prefer to use loose equality, and that is for checking against null and undefined. So what I'm going to do is say val is, for now actually, let's say strictly equal to null, and let's say here it was null. And if I log this out, we don't get anything because this was not null, but if I make the val null, we would say it was null. And this is a common check we want to do to check if some value actually exists. But the problem is we've seen that we have null and undefined happens a lot as well. So if we said undefined here, well, now it's not null because undefined and null are different types. They're not the same. However, if we used loose equality here, a loose equality check against null actually is going to check for null and undefined because they have different types, but they're considered to have the same value. So because of this, we get it was null when we run this. Same thing if we had null here, we would get it was null. But if we had any other value, even things like an empty string, we would get nothing here because empty string is not loosely equal to null. Same thing with values like 0. This is not loosely equal to null. So essentially using this loose equality operator with null is a way that we can implicitly check for undefined, which is something we oftentimes want to do when we are checking for null. But like I said, this is essentially another stylistic choice. Some people prefer to always use loose equality for null checks, while other people say just never use loose equality at all and explicitly check for null and undefined. Personally, I prefer to use loose equality for these null checks, but either way is perfectly okay. The one rule I would say though is just never use loose equality for anything except for these null checks. For everything else, use strict equality and strict inequality. Next, I want to look at a few more operators, specifically less than and greater than, as well as less than or equal to and greater than or equal to. So here we have a console log of 5, the less than sign, and then 10. And as you might expect, this is going to log true. So this is the less than operator, and it takes a value on the left and the right, and it returns true if the left is less than the right, and false otherwise. So if, say, this was 15, and we run this again, we get false. And if they were the exact same, so both of them were 10, we would also get false because these are still different. And if they were different types, so for example, 10 is less than the string of 10, we still get false. But if we did 10 is less than the string of 100, we would get true. So it does its best to make these like they're the same type. And if this was the string of 1, we again get false. Now, if these were both strings, so if say over here we had the string of ABC, and over here we had the string of DEF, then it uses the string values for that comparison. So this is true, essentially because A is less than D. But if this was, say, the letter E, we'd get false because E is not less than D. A fun sort of interesting one here is if over here we had the string of, say, 22, but then over here we had the string of, say, 8, you would say, okay, 22 is not less than 8. But if I run this, it's actually going to be true. And the reason for that is, again, because they're both strings, so it's comparing them in lexicographical order. So first it says, is the first character of this less than the first character of this? And it is, so if you think about how we sort of like do alphabetical order, it's the same thing. Once you find that the first character is less than, you don't need to do anything else. So it's not actually comparing these as numbers, it's comparing them as strings, so we get true here. But anyways, this isn't something we'd typically want to be doing most of the time with these operators. We want to use them with actual numbers. So let's say we have 10 here again, and let's go back to, say, 5 over here. And now in addition to this less than operator, of course, we do have greater than as well. So it's going to be the greater than sign. We can see 5 is not greater than 10. If we do 10, that is also not greater than 10, but say 100 is in fact greater than 10, so now we get true. And in addition to those operators, we also have greater than or equal to and less than or equal to. So if we add an equal sign after the greater than sign, this is now greater than or equal to. If we run this again, it's still true because 100 is greater than or equal to 10, but the difference is if these were the same, so if we have 10 and 10, this is now true because 10 is greater than or equal to 10. It is equal to it. And then we could say maybe just 1 here, and this would be false because 1 is not greater than or equal to 10. And then of course there's less than or equal to, so if we change this to be less than and then the equal sign, this is now going to be true because 1 is less than or equal to 10. 10 is still going to be true because 10 is less than or equal to 10, but say 100 is false because 100 is greater than 10. And again, this is going to use loose equality, so if say we had 2 10s, but this one was the string of 10, it is going to be true. So that is something to be aware of. In general, I would try to avoid having different types as the 2 operands, just because it can cause some sort of weird behavior from time to time. And I also wanted to show how we typically actually use these operators, so I'm going to get rid of this code. Let's say we have an age, so I'm going to say let age equal 26, and one thing we oftentimes do is use these in an if statement. So let's say maybe if age is greater than or equal to 18, then we can log out something like console.log, this is an adult. And then if I run this, you see we get this is an adult. Same thing if we had 18, but if say we had 17, now we don't log anything because we do not get into this if check. So oftentimes the places we're going to use these operators are places like if checks where we need to check some condition. Next, we're going to look at the logical operators, which essentially just allow us to combine other operators we've seen so far into single statements that return some Booleans to us. And specifically, these are going to be and or operators. So for example, here we have an age of 26, and we have a country of USA. And what I want to do is say if, and we want to check that this is an adult. So we're going to say age is greater than or equal to 18, but then we also want to check that this is an American. And how do we check that their country is the US? Well, we'd have to check that country is equal to USA with the strict equality operator, but we already have a condition here. And the way we can do this is by using logical and to combine these conditions. So it's going to be 2 ampersands, so 2 of the and sign, and then we're going to say country is strictly equal to USA, and in this case, let's console.log American adult. And if I run this, you can see we get American adult, but if say this was 17, we would get nothing. And if this was not USA, so let's just add another character here, we also get nothing. But if we go back to 26 and USA, we do get American adult. So these 2 ampersands are logical and all it says is check to see if the thing on the left is going to be true and the thing on the right is going to be true. And if both of these things are true, then the entire thing is true. And we can even chain these together to make it even longer. So we could say another and maybe this one we want to also check that they're not above some age threshold. So let's say and age is maybe less than 30. And let's say this is an American young adult now. And we can run this and we get American young adult. But if say this was 30, we would now get nothing because one of these 3 statements was false. And now in addition to logical and, we also have logical or. So I'm going to remove this age is less than 30. And I'm going to change this from the and signs to 2 vertical bars. And this represents or logical or. And what it is essentially the same thing, except for we just need one or the other to be true. So we need age to be greater than or equal to 18 or country to be USA. So let's say this is American or adult. And if we run this, it is true because at least one of them is true, but in this case, actually both of them are true. But if even only one of these was true, so say this was now 17, which is not greater than or equal to 18, we run this, we still get American or adult because country is USA, so this part is still true. But if we change this to have another A, now we get nothing because neither of these 2 statements was true. But then again, of course, if we made one of them true, we would again get into this if statement because one of the 2 values was true. And now, of course, if we wanted to, we could sort of chain all of these things together. So we could come back down here and maybe add in that young adult stipulation again. So let's say and age is less than 30. And then we can say American or young adult. But one thing to note here is there's sort of a weird thing with order of operations. And typically I don't even want to think about what exactly the order of operations is going to be here. So what I would do is put this entire thing in parentheses to say that this is sort of one value and then this is one value. Sometimes you will need the parentheses, sometimes you won't, just again, due to order of operations. That works fairly similar to how order of operations works in math, but I think it's just much more verbose and easy to understand if you use parentheses to sort of denote what is a single entity. So in this case, all of this represents, is this a young adult? And this represents, if they are an American. So we can run this and we get American or young adult. But if, say, we don't have them be an American, we still get into this because it's still a young adult. But if this person was now 31, we no longer get into this because this is false and this is false. And now one other thing we could do here is actually take these out and make them into a variable just to make it easier to read. So let's say young adult. And actually, I think it'll be even better to prefix this with is, just because I think the is prefix makes it more clear that this is going to be a Boolean value. And we can come up here and say let is young adult. And then I will paste all of this in, and we no longer need these parentheses because I think it's more clear like this. So we can say if this is a young adult or they are from the USA, then console log American or young adult. And of course, this works the same way, so we aren't going to get anything right now, but if we make them have the country of USA, again, we get American or young adult. And then of course, if we make this back to a young adult, well, this is still true because is young adult is true and country is USA. So because just one of the two values, but in this case, both of them were true, we get into the if statement. Now there's one final logical operator I wanted to show in this video, and that is the not operator, which does just like it sounds like it does. It just gives you the opposite value of what you otherwise would have gotten. So for example, we have is young adult, and the way not works is we actually prefix whatever the value is. So we can add an exclamation mark before it, similar to the exclamation mark we used with the logical inequality operators. And now we can see this is now the opposite. So we're checking, is this not a young adult or is the country USA? So American or not young adult is essentially what this represents now. And if I run this, we do end up getting true because age is 18. So is young adult is actually true. So this whole thing is false, but then country is still USA. So this part is true and it is or, so this is going to still overall be true. But if say this was USA with another A, we now get nothing because this is false as well as this is false. But if say we wrapped this whole thing in parentheses and then negated this with the not operator, now this is not American or not young adult. And we can run this and we do end up saying that this is true because one of these two things is true. So is young adult is true, but we invert it. So this whole thing is false. And country is USA is false, but we invert it. So this one is true. And it's worth noting that with this country is strictly equal to USA negated, this is actually exactly equivalent to using the strict inequality operator. So essentially all there is to take away from this video is that we have three primary logical operators we can use. We have logical and logical or, which allow us to combine conditions together. And then we have the not operator, which allows us to take whatever value we have and flip the Boolean to be essentially the exact opposite of what we previously had. And we'll use these a lot when we are sort of working with the control flow of our program and trying to decide what exactly we want the code to do based on certain conditions. Okay, so next up, we're going to look at something known as a switch statement or a switch case statement. And these are very similar to if statements, although they're used in slightly different scenarios. So here we have some food, and we want to do something different based on if that food is a fruit, a vegetable, or if we just don't know what it is. And the way we can do this is, well, for one, we could use an if statement, but another option is to use a switch statement. So we're going to say switch, and inside of the switch, so we're going to have parentheses, we're going to give it some case, so some value we are switching on. And this can be any type of value, but for now we will use our food, and we can open it up with curly braces like we do with an if statement. And now we use what are called cases. So we can say case, and this is going to be, for example, banana. So in the case that our food is a banana, what we want to do is what's below this case statement. So for example, we can say console.log, and we can just log out that this is a fruit. And you'll notice we use the colon here rather than using curly braces. So this is a case of what this is. And if I run this, you can see we get fruit. And now I could come down below here and maybe add another case statement. Maybe in this one, what we're going to do is say that this is a carrot. And in the case that this is a carrot, what we want to do is console.log that this is a vegetable. Now there's one thing to note here, and that's that the cases don't work like if else. So just because we got into the banana case doesn't actually end what we are doing. So if I run this, you can see we actually still log out fruit and vegetable. So what happens is we get into the first case, which is banana, and we log out fruit, but that doesn't actually end the execution. It just keeps going. So even though this isn't a caret, what we're going to do is once we're in a case, we sort of just ignore all the cases after that, and we just keep running the code. So the way to avoid this is by adding a break statement. So this says, when you get to the end of this case, don't do anything else. So now we get just fruit. But if I change this to say caret, now we get vegetable. So typically we want to add a break statement to the end of every single one of our cases. And then at the end, we can also add a default case. And this is what we do in the case that we did not get into any of the previous case statements. So essentially, this is like the else in if else. So for example, we can say console.log unknown food. Now if we run this, we get vegetable because we have a caret. But if we say just the letter A here, we get unknown food. And then if we say banana, we get fruit. And one thing that is nice about case statements is that they are very easy to combine. So for example, we know that there's other fruits. So we could say case apple. And now that there's no break statement after apple, this is essentially all one big case. So now if we have apple or banana, we are going to get into this fruit case. So we can run this, we can see we get fruit. And if I made this say apple, we still get fruit. And of course, everything else still works as well. So caret will give us vegetable. So one of the common questions with switch statements is, why do these things even exist? And why would we use this instead of using an if statement? And the answer is that in most cases, you can use either, but there are cases where a switch statement makes more sense. And also in some cases, it will actually end up being a little bit more performant. So in the case we have some value and we're just checking it against a bunch of different options. So for example, we have this food and we're checking it to see if it's going to be a fruit or a vegetable. A switch statement is usually a better option here. For one, it means we actually only check this food value one time. So it actually can end up being more performant in some cases. But also I think it just looks a little bit cleaner than having a bunch of else if statements that are all essentially the same thing, checking the food against some other value. On the other hand, if statements tend to be a little bit more generic. So when it doesn't fit necessarily as a switch statement, the if statement should be sort of the go-to, which honestly is going to be the vast majority of the time. I don't find myself really reaching for the switch statement all that often, but they are good to know about as they can be useful from time to time. Next, I want to talk about something known as a ternary operator, or sometimes called the conditional operator. And this essentially works as an alternative to if-else statements in some particular conditions. So for example, here we have let age equals 26. Then we have this age group that we set to adult if the age is greater than or equal to 18. Otherwise, we set it to child. And then we log out the age group so you can see we have adult. And if I made this a child, say 15, now we have child. But this whole thing is just sort of clunky. We have this whole set of if-else just to set this age group variable. And then we had to do the actual declaration of the variable up here and then give the initial values down here. The whole thing is just very sort of clunky. It doesn't feel very clean. So an alternative to this is to use what is known as a ternary operator. So when we actually create our age group, what we're going to do is first have our conditions. We're going to say let age group equal age is greater than or equal to 18. And then we use a question mark. And this question mark essentially says, check to see if this is a true value. Check to see if this is true. So is age greater than or equal to 18? If it is, make the value whatever is next. So in this case, it's going to be adult. And then otherwise, so essentially our else is going to be a colon. So otherwise we want child. And this code is essentially the equivalent of all of this code. So we can get rid of all of this, run this, and we still get adult. And if, say, we change this back to 15 again, we again get child. So to go over this again, what it's actually doing is first we have a condition. And if this returns true, then we go to the first value after the question mark. And if this is false, we go to the second value after the colon. So in this case, it is going to be false. So this is false. So we come after the colon and we get child. But if this gives us a true value, then we go to the value immediately after the question mark. And you'll see these ternary operators used in a variety of different circumstances, but where I do think they really shine and work the best is things like this, where you have some value that you're setting, based on some condition, and there's two possible outcomes. So in this case, the condition is age is greater than or equal to 18, and these are the two possible outcomes. So for scenarios like this, a ternary operator works very well, and it's just a lot more concise than using a full if-else statement or a switch case statement. Next, I'm going to talk about the idea of looping. This allows you to run the same code over and over again until some condition is met. And the most basic form of these is known as a while loop, which is what we'll look at in this video. So here we have a random number, and we set this equal to math.random. And what math.random does is it simply generates a random number for us between 0 and 1. Don't worry too much about this right now. Just know that that's what it's doing. So random number is a random number between 0 and 1, and we log it out. So you can see here we have 0.875, but if I ran this code again, we would get a different number, and every time we run this code again, we should get some different random number. But now, what if, say, we wanted to do this over and over again, and we wanted to keep logging out random numbers, and we wanted to see sort of the log of all of the random numbers we get until we pass some threshold. So say, until we have a number greater than 0.5, we want to see all of the random numbers we got. How would you do that? Well, we know that, say, in this case, we got 0.46, so we need to log out another number. So we could do this all again, of course, without the let to not redefine that variable. But what if the first time we did get a number over 0.5? So let's run this again. Okay, so this time the first number was 0.81. So that was already above 0.5, so we wouldn't even need this. So maybe this code needs to be in an if statement. But then what if both of the first two numbers were less than that threshold? Then do we just add another if statement with more of the same code? And what if we need to do it like 10 times? Do we just keep adding more and more if statements? Well, no, of course we don't want to do that. It's going to get very messy, and theoretically there's no end to how many if statements we actually need. So the way we do this is with a loop. And specifically, we're going to use a while loop, which works very similar to an if statement, but it does exactly what we want in that it keeps running. So we're going to say while, and then it takes in some condition just like an if statement. And in this case, we want the random number to be less than our threshold. So let's say 0.5. And what this is essentially an if statement. So just like the if statement, if this is true, we do the code inside. But more than that, if it stays true after doing the code inside, we do it again. And we just keep doing it until this condition is no longer true. So until the condition is false. So in this case, what I want to do is essentially all of this code. So I'll paste this in here, make this look a little bit cleaner. And actually, we don't even need to do it out here anymore. So we could just say let random number, for instance, although this isn't going to work perfectly because random number is never going to be less than 0.5 initially. So we need to initialize this to some value that's going to make random number less than 0.5. So let's just say it is 0 initially, and we can run this, and you can see we get a bunch of different numbers in the console until we get one that is greater than 0.5, or greater than or equal to 0.5 technically. And we could run this again, and you could see we'd get different numbers. Sometimes we might only get one number, but it is doing what we want of just logging out random numbers until we get a number that is above our threshold. Okay, but you might not love this idea of having to set random number equal to 0 initially. It just feels a little bit wrong, but it also would feel wrong to have two copies of this code, so to have this also outside of the while loop. That feels a little bit strange too. So there's actually another form of the while loop that can handle this for us, and that's known as a do while loop. So we say do, and then we put the code inside of the do instead of inside of the while. So this code will go in here, and then the while is simply the condition at the end. And this is usually going to be all on the same line like this. So this works basically the same way as a standard while loop, except for one thing, and that is that we guarantee that this code runs at least one time. So we say, do this while this is true. Instead of while this is true, do this thing. So we have this extra sort of do block here that makes sure that this code runs at least one time. So because we know this runs at least one time, we don't actually need to initialize random number to 0. Instead, we can just say let random num, and then we'll have the do while loop, and this will work just fine. So it is going to first of all do this, and then it's going to check if the condition is true. If the condition is true, it's going to do this again. And it's just going to keep repeating that over and over again. And we can see if I run this code a few times, we'll see it is doing exactly that. So sometimes we get a lot of numbers, Other times we'll get less numbers or even just one number, but it's doing the same thing as before, just without having to set random number equal to 0 initially. And now one other question you might have is, why do we even need let random number out here outside of the do while loop? What if we just did something like this? And this feels like it should work, but there's one problem with it known as scoping, and we'll be going more in depth on scoping a bit later, but the key idea is simply that whenever you define a new variable, so whenever you declare this new variable, it is only going to exist within its current scope. So when we did this at the top level, this variable existed everywhere. But inside of a do while loop or a while loop, or really almost any time that you have curly braces, that is only going to exist within those curly braces. So what's the issue with that? Well, we have this while portion that is checking random number, but random number does not exist outside of this sort of do block. So while is not able to check random number. So this is actually just going to throw an error because it is trying to find random number, and we can see random num is not defined. So that's just a small common pitfall to be aware of, but we can put this back and of course it will work again. And overall, we do tend to use the standard while loop far more often than the do while loop. In fact, I can only think of a few times I've ever actually used a do while loop, but they are useful from time to time, so I do think it's good to know about both. Next up, I want to look at another way to loop known as a for loop. So a for loop is sort of an alternative we have to the while loop. It does something very similar, but in a slightly different way. So here we have a while loop example. So we say let I equal 0. So we have this variable called I set equal to 0. And just as an aside, I is a very common variable name we tend to use when we are looping for an index. So this is sort of our current place in the loop. And we are looping until I is less than 5. So while I is less than 5, we log out I, and then we add 1 to it. So I plus plus. And you can see the output down here. We log out 0, 1, 2, 3, and 4. And this works perfectly fine. If you want to do it this way, you absolutely can. But this is actually such a common looping pattern where you sort of have some variable and then you loop until something happens with that variable. And at the end of each iteration, you increment that variable. And because it's so common, there's actually a special syntax for it known as a for loop. So we can come down here and we can say for, and a for loop has 3 main parts to it. So first of all, we have the actual initialization of some looping variable. So we can say let I equals 0. So this is all inside of the parentheses. So where the condition would go for a while loop, we start by creating some variable such as I is equal to 0, and then we add a semicolon to show that that is sort of the end of this part of the line. And then after that, we are going to have the condition. So for example, I is less than 5. And then we add another semicolon. And finally, we have whatever the incrementing part is going to be. So this is going to be code that runs at the end of each iteration. So we can say I plus plus. And this one does not need a semicolon just because it is sort of the end of all of the content that goes inside of these parentheses with the for loop. And then we open up the loop and we add whatever code we want. So we can say console.log I. And this code right here is essentially equivalent to this code. There are some very small differences, but for the most part, these two pieces of code are going to be completely equivalent. So I'm going to get rid of the while loop. We can run this and you can see we get the same output 0, 1, 2, 3, and 4. So again, what this does is it creates a variable that we can use within our loop. And then we have a condition that we're going to check with each iteration to determine if we continue iterating or not. And then we have some code that we run at the end of each iteration to actually change the value to get closer to this ending point. And a key point here is that this code runs after the iteration. So you'll notice the first output was 0. So we log out 0. So that means we set I to be 0, and then we got into the loop and we log out I, and then after that is when we increment I. This is also why we never end up with an I value of 5. So if we got to 5, 5 is not less than 5. So we never get into the loop when I is 5. Because again, I became 5 at the end of the previous iteration, which would have been where I was still 4 when we were logging out. Another thing that's worth noting is what would happen if, say, we started with I is 5? Well, we would get nothing. So this condition is checked on the first iteration. So this doesn't work like a do while loop where you just run the thing the first time no matter what. It works like a while loop in that it checks the condition even on the first iteration. It's also worth noting that we aren't confined to this exact style of loop. We can do other things with the for loop. This is just how it's most commonly used. So for example, let's put this back to 0 and maybe say I is less than 10. And instead of I plus plus, we could do something like I plus equals 2. So this is now going to add 2 to I with each iteration. So you can see we now have 0, 2, 4, 6, and 8. And then 8 would be the last one because at the end of logging out 8, we do I plus equals 2, making it 10. And 10, of course, is not less than 10. So that ends our iteration. And we can even do things like looping in reverse. So maybe we want to start with 10 and we want to go until we get to 0. So let's say I is greater than or equal to 0. And instead of I plus equals 2, let's actually go backwards. So let's say minus equals 2. And now we'll get 10, 8, 6, 4, 2, and then 0. And you'll notice also that because I used greater than or equal to instead of greater than, we actually did end up logging out 0 because when we got to 0, we say, is 0 greater than or equal to 0? And it is equal to it. So we ended up logging out 0. So that's all there really is to a for loop. For the most part, it works very similar to a while loop, just with a little bit different syntax, sort of specialized for this idea when we are initializing some variable and incrementing or decrementing that variable with each iteration, and then checking some condition with each iteration as well. And really, for loops are going to shine in times when you know exactly how many iterations you're going to be doing. So for example, you know that you're going to be iterating through some entire list of something, or you know you're going to be iterating, say, 10 times. In those types of cases, a for loop is oftentimes the best option, whereas a while loop is oftentimes the best option when we don't know how much we're going to be iterating. So for example, we're going to iterate until some variable becomes true, but we don't know exactly how many times it's going to take to get there. And in that case, it's likely to be a better choice to use a while loop. But that said, oftentimes it is sort of a stylistic choice and either could end up working. Next up, I want to look at two special keywords we can use within our loops, both for loops and while loops, to sort of change the flow of how exactly they work and how they iterate. Now, oftentimes we don't really want to use these too often. It's sort of considered breaking the standard flow of our code, the standard execution flow. It can make code a little bit hard to read, but that said, there are of course times to use them. So here we have a for loop from 0 to 5, and we just log out I. And the two statements we're referring to are continue as well as break. So let's say maybe this is what we wanted to do, but we wanted to skip over the number 3 for some reason. And the way we could do this is by saying if I is strictly equal to 3, so inside of our for loop, we're going to nest an if statement and say if I is 3, well, then we don't want to do anything. In that case, we're just going to continue. And what continue is going to do is say, just move on, go to the next iteration. So if I run this, you can see we now skip 3. And it is worth noting that this is essentially equivalent to, instead of using this continue, putting this itself in the if statement and then flipping this to say if I is not 3, then log out I. So these are essentially equivalent, but that won't always necessarily be the case. For example, if we had a lot more code here, it might make more sense to use the continue statement rather than nesting all of our code inside of this if statement. But okay, I'm going to put this back how we had it. Now I want to look at one other statement, and this is actually one we've seen before. And that is going to be the break statement. So we saw break with switch cases, but we can also use break in a loop. And what break does is it just ends the loop. So if we break when I is 3, you can see now we never go past 3. So we just log out 0, 1, and 2. So in a sense, this code is actually the same as if we added some extra condition to our for loop to say stop if I is 3. However, it is actually a little bit different in that we can put this code anywhere in the for loop. So for example, we could have some other log at the top here that, I don't know, does something. And now you'd see we still get this does something before we get to I equals 3 and we break. So essentially we get this extra iteration or half an iteration at the end where we log out does something and then we never log out I though because we break here, meaning we completely end the loop at that point. Now, most of the time we don't need break and we don't need continue. Most of the time we can just handle this in our actual loop itself and not have to deal with having these breaks and continues that sort of mess with the flow of the code. However, of course, there are exceptions to everything and they exist in the language for a reason, so there are times where you might need to use them. That said, if you do find yourself using break and continue, especially if you're using them a lot, do try to sort of reevaluate your code and see if there might just be a cleaner way to write that code without them. But of course, you might need them from time to time. Next up, I want to talk about functions. So what a function is simply a reusable block of code. So here we say let name equal Connor, then we log out welcome and hello plus the name using this template literal. And then you can imagine there's some more code here doing something. And then we log out welcome and hello name again. So this code is identical to this code. And this is, of course, sort of a contrived example, but you could imagine there's something happening where we're doing the exact same thing 2 times. You can see if I run this, of course, we get welcome, hello Connor, and then again, welcome and hello Connor. And because this code and this code are the exact same, what we can do is we can actually refactor it into what we call a function. So what I'm going to do is come up here, and we're going to use the function keyword, and then similar to a variable, we give the function a name. So in this case, let's say welcome, and then we will add opening and closing parentheses, and then similar to an if statement, we are going to have curly braces to open up our function block. And this here is a function, so it is our sayWelcome function, and currently it doesn't actually do anything, but what we can do is just take this duplicated code, and I'm going to cut it from here, and paste it into our function. And now instead of that code that we had 2 times, we can simply say welcome, and then we add the opening and closing parentheses and a semicolon, and this is going to run this function, meaning it's going to run all of the code inside of this block. So this is essentially exactly equivalent to this here. And what that means is we can reuse this. So down here, we can do the same thing. We can say welcome down here. And now we are able to just have this code exist in one place. And you can see if I run this, we get the same output again, welcome, hello Connor, and then welcome and hello Connor again. So there's a lot more we can do with functions, and we'll be seeing that through the next few examples and through the rest of the course. But at a very high level, the idea of a function is to take some code and put it in a reusable block so we can reuse the same code multiple times. Additionally, you'll see that sometimes we use functions for other reasons as well. For example, sometimes we use a function when code doesn't actually need to be reused, but simply because we want to be able to take some code block and sort of combine it all together and give it a single name just because it can help with readability. Next up, I want to talk about what's called a parameter to a function. So here we have a width and a height representing the width and height of some rectangle. We calculate the area as width times height, then we log out the area of the rectangle is, and then our area. And maybe we want to make a function for this. So let's say function calc rectangle area, and then we're going to paste this code inside of here. So let's put this inside of the function, then we can call the function. So we can say calc rectangle area, we can run this function, and we can see we get the same output. The area of the rectangle is 50. But now, what if we had multiple rectangles of different sizes? Well, we would somehow need this function to know which rectangle it needs to use. And the way we can handle this is using something known as a parameter. So a parameter is simply a variable that is created for the function that is passed into the function when it is invoked. So here we are invoking the function, and at this time, we can tell this function, hey, here's the width and the height I need. And the way we do this is with these parentheses in the function declaration. Inside of here, we create whatever variables we need. So for example, we can say we have a width and a height. So now this function is going to use this width and height. And when we call the function, we are going to pass in a width and height. So we can say width and height like this, and we get the same result. Or instead of having this all together, we could do this completely inline. So we could say the width is 5 and the height is 10, and we'd get 50 again. If say we made the height be 100, we would now get 500 because this here is our height and this is our width. So if we have multiple parameters, the order is going to matter. The first value we pass in corresponds with the first parameter in the function declaration. the second value we pass in corresponds with the second parameter. And when we actually pass in these values, this is known as an argument. So oftentimes you'll see the terms parameter and argument be used sort of interchangeably, but they do mean two different things. So a parameter is here in the function declaration where we say, hey, we're going to need these variables to run this function. And an argument is when we actually pass in a value to be those parameters. And now because we have these parameters, we can actually run this function multiple times with different rectangles. So we could do another rectangle, maybe this one is 2 and 20, and we'd see we now have two rectangles, one with an area of 500 and one with an area of 40. So by passing in these arguments, which become the parameter values within the function, we can have this single function essentially do multiple of the same thing, but in slightly different ways based on how that function is invoked, meaning what arguments we actually give it. Now, one additional thing I wanted to mention is that JavaScript generally as a programming language was built for the web. And on the web, we want to have as few errors as possible. So because of that, oftentimes a lot of things that in other programming languages might create an error, in JavaScript, it just sort of tries to do its best to handle it, which sometimes can be good and sometimes can be bad, but it is just something we need to know how to handle. What I'm talking about specifically here is if we are missing an argument, it's actually not going to throw an error. Instead, it's simply going to give us the value of undefined. So what I'm going to do is remove this bottom one here, and let's say we forgot to pass in a height. And what you might expect to happen here is that we would throw some error. But that's actually not going to be the case. So what I'll actually do is just comment out this code so that we can see things a bit better. Let's say console.log, simply our width and our height. And you can see if I run this, we get 5 and undefined. So our height is currently undefined because we did not pass one in. And if we don't pass anything in, we just get undefined 2 times. So just sort of a gotcha to be aware of is that when you are invoking a function, you need to actually check that you are passing in all of the arguments that it actually required. Additionally, if you're writing a function and you can't guarantee that it's always going to be used in the correct way, one thing you can do is to use some if checks. So you could do something like if width is null or undefined. So remember, if we use loose equality with null, it's also going to check for undefined, or height is null or undefined, then maybe in this case, you want to do something else like tell the user, hey, you need to give us a width and a height. Alternatively, another option instead of doing this is that you can actually have default values in our parameters. So for example, we could do something like height is equal to 10. And what this is going to do is say, if there is no height given, make it be 10. So if I run this now, you see we get undefined and 10 because we did not pass anything in. But if I say put a 5 here, we now have 5 and 10. So width is 5 and height is 10. But if say I did 5 and 50, well, now we actually did put a value here. So we're not going to use this default value. So if I run this, we do now get 5 and 50. But that said, it doesn't always make sense to have a default. So if we go back to our function doing what it was intended to do of calculating the area of a rectangle, it doesn't really make sense to have a default height. Maybe you can make the height default to 1 and also make the width default to 1, but I'd argue even this doesn't really make sense. Why are we defaulting to 1? If there is no width or no height given, I think it makes a lot more sense in this scenario to just give some error message in some way to tell the user, hey, I need these values, because we're sort of just guessing what the width and height should be. So most of the time you'll see we don't tend to actually use default values like this, but of course on occasion they can be useful. Next I want to talk about something known as scope. So scope simply means where our variables are and are not going to be visible. So where we can and cannot access them and change them and all of that. So here we have a function called sayHello. It is a first name of Connor, and we log out hello and then the first name, say hello, logs out hello, Connor. And the important point to note here is that we have one variable that we created in this function. And this variable is what's known as a function scoped variable. So this only exists inside of this function. So if say we came down here and said console.log our first name, this is just going to give us an error. It's going to say reference error, first name is not defined, because this does not exist outside of the function. So we cannot actually do that. However, if something is scoped higher than the function, so if we came up here and said, let first name equal Connor, and then we get rid of this first name here, well, this is now what's called a globally scoped variable. So this variable is accessible in smaller scopes. So it's accessible inside of the say hello function, even though it's not created inside of that function. So we get hello Connor still. And if I console log that variable down here, we can say our first name, you'd see we'd log out Connor because this variable is scoped globally. Now, in addition to function scoping, so scoping created by functions, there's also what we call block scope, which is essentially scoping created by any curly braces we use. For example, with if statements and for loops, and really anywhere in our code that we have these curly braces. So for example, let's come down below here. Actually, we can just remove all of this. We can do something like if, and I'll just say if true so that we always get into this if statement. Let's say let num equal 10. And then we could say console.log our number. So console.log num, and of course we log out 10, and we do of course get into the if statement because it's just if true. However, if we move the log outside of the if statement, we again are going to get a reference error of num is not defined because num only exists within this if statement. And the same is going to be true for loops. So for example, if we were to say for let I equal 0, I is less than, let's say 5, and I plus plus. And then inside of here, let's say let num equal 5, and then console.log out our number. Of course, we log out 5 a bunch of times. However, if we instead move this console log to be outside of the for loop, we would end up with a reference error. Num is not defined because again, num only exists within this for loop. Now, something that is interesting is if we were to log out I, this is also not going to be defined. And the reason being is that this I is essentially created inside of the for loop. So even though this is sort of like at the declaration level of the for loop, I only exists inside of the for loop when we create it using let. So therefore, we cannot log I after the for loop. So really at the most basic level, just know that whenever you have curly braces, it creates scope. This is going to be in loops, this is going to be in if statements, pretty much anywhere you have curly braces, and any variables you create with let inside of those curly braces only exist inside of the curly braces. Additionally, for the most part, when we create variables as sort of parts of different declarations, those are also going to only exist inside of that scope. So for example, this let I equal 0, I only exists inside of the for loop. Next up, I want to talk about the return statement and return values. So returning is a way to exit a function and to give some value back to wherever invoked that function. So for example, here we have this function called calculate total price. And it takes in a price and a tax rate. And the tax amount is going to be our price times that tax rate divided by 100. And the total price is going to be the price plus however much we have to pay in taxes. And then we just log out the total price. So for example, calculate total price with a price of 10 and a tax rate of 10% is going to give us a total price of $11. And of course, we could use this function multiple times. So we could say, maybe this one has a price of $100. Now we get $110 because of this 10% tax. But what if we need to actually use these values? Right now we just print them out. But what if down here we need to do something? For example, when we're building websites, we might need to populate this price onto the page. And then when the user actually decides to buy the thing, maybe we need to send that data to the server. Maybe there's a bunch of different stuff we need to do with this price. So we need to somehow get it out of this function instead of just logging it. And the way we can do that is using a return statement. So instead of this console log, what we're going to do is say return and then our total price. So what this says is make the value that is the invocation become total price, as well as just end the function. So for example, if here we were to wrap this one in a console.log, we would end up getting the same thing. So we still log out 11. Or alternatively, we can say let total price equal, and now total price is going to be the return value of this function call. So it is this total price, and we could say console.log total price, and here we have that value of 11. So now we have actually captured this value from the function outside of the function so that we can now use it in other places in our code. Additionally, this has ended the function. So anything after this would no longer occur. So if we said console.log and just here, just so that we can see what happens, nothing happens because we never get to this code because return ends the function. So anything after return will not be executed. And oftentimes our return ends up being the end of the function anyways, so we don't really take advantage of the fact that nothing after it happens, but sometimes we actually do want to take advantage of that. For example, one thing we do a lot is something known as a guard clause, and we don't necessarily need one with this particular function, but just to show you, we could do something like if our tax rate was 0, so if there were no taxes, then maybe in this case, we simply want to return our price. And this does the same thing, right? Even if we had a 0 tax rate here and we did not have this if check, the function's still going to work. We're going to get 10, but now we're going to return a little bit earlier. So you can see if we say console.log here, calculating, we never actually log out calculating because we simply return the price here. Whereas if, say, our tax rate was, again, 10%, we would actually log out calculating because in this case, we get down to this code. And this example is a little bit contrived, so it doesn't really matter here. But you could imagine if we had some very complicated calculation, but there were some edge cases where there's just no calculation to do at all, it could be much more efficient to say, hey, if we know that the parameters are these certain values where there's no extra work we need to do, just return now so that we don't have to do all of the extra work, and that can become more performant. One other thing I wanted to note is that if you return without a value, so if, say, I just returned here, it's actually still going to end the function, but it's just going to return undefined. So if we run this, we still get 11 because we got down here. But if, say, we made our tax rate 0 again, now we actually just get undefined because this is going to end the function, but we didn't tell it what to return. And we know JavaScript, usually if it doesn't know what value we want, it's just going to default to undefined. So that is what it does here. And this can actually be useful if there's some time where you need to end a function, but you don't actually have some value to return. You just need to say, hey, I'm done with this thing. I've done everything I need to do, but I have nothing to actually return up to where the function was invoked from or where it was called from. So in that case, you can just return undefined by simply having an empty return statement. Next, I want to talk about something known as a callback function. And a callback function is simply when we pass one function in to another function as a parameter. So for example, here we have an add function and we have a subtract function. And you could imagine we have a bunch of different functions like this. We're making some kind of like calculator application. And then maybe we want to have a generic function. So something like function calculate, and this is going to take in our two values, so a and b, as well as we want it to take in the operation. So let's say operation, and we can open up this function. So we want this to be a generic function that can take in any operation. And now, how can we do this? Well, with what we've seen so far, we could make operation be a string, and then we could use a switch statement to switch on what string we get, and then call the different functions. But the problem with that is that then whenever we want to add a function, we have to update the calculate function. The calculate function is going to get very long. And then it's like, what's even the point of these functions if we still have the switch statement inside of calculate? So what we can do instead is we can say that operation itself is going to be a function. And this works because functions in JavaScript are what we sometimes call first-class citizens, meaning we can just pass them around like normal values. So for example, we could say return, and then we're going to, again, remember that operation is a function. So we're just going to call operations. We're going to say operation, and then we're going to pass in the two values. So we know operation is going to take in an A and a B value. So now we can use the calculate function with any A and B, as well as some operation that takes in that A and B value. So for example, we could come down here and we could say console.log calculate, and then we are going to pass in to calculate, let's say maybe 5 and 10, and the add function. And you'll notice when I do this, I'm actually not using the parentheses here. I'm not calling the add function. I'm not doing something like this. I'm simply passing in the name of the add function. So the name of a function works sort of like a variable. Now, if I run this, you'll see we get 15. And if I change this to say subtract, well, now we get -5 because it's doing 5 minus 10. And what's sort of nice about this is it allows our calculate function to be much more generic. So for example, you could imagine we have some big calculator application with hundreds of these functions, and we want sort of one main calculate function, but we don't want it to have to switch on all of these hundreds of different functions. We don't want to have to add switch cases every time we add a new function. So because of that, we can just make this generic function that's going to be much simpler. That said, this is a bit of a contrived example, but in a little bit, we will see more ways to use callbacks within JavaScript that are very, very powerful. Next up, I want to talk about something known as an anonymous function. So an anonymous function is simply a function that we never give a name. So sometimes you'll see functions like this. So our calculate function referred to as a named function because it has a name, but we can actually define a function without giving it a name like this. So we can just say maybe function, then we take in a and b, and let's return a plus b. So this is our add function. And this is actually a valid function, even though it has no name. You'll notice that VS Code is actually underlining this. So it's saying that this is an issue because this is actually unusable code. This function cannot be used because we have no name for it. So there's no way to actually call it. In some environments, this will throw an error, in some it won't. But the point is simply that this is actually not useful. You cannot use this function. So then why do we even have anonymous functions? Well, primarily we use them with callbacks. So let's say we had a call to our calculate functions. Let's say console.log, calculate, and then we're going to pass in maybe 5 and 10 for a and b, and then we can pass in this entire function as our operation. And then we can run this, and you can see we get 15. So operation, remember, is a callback function. So we are just going to pass in this entire function expression. So we're going to pass in this entire function as that operation, and you can see that does actually work. And you might be saying, well, why would we want to do this? And some people prefer to essentially never actually use these anonymous functions, and that's fine. But also some people prefer to use them in times where you have some callback function and you only actually need it one time ever. So it's like, why would you define this whole function when you just need it one time? Now, I also wanted to show that it is actually possible to essentially give a name to these anonymous functions. So what I'm going to do is cut this from here and put it back at the top level. And we could actually just save this in a variable. So we could do something like say, let add equal our function. And now because of this assignment operation, add is going to hold whatever is on the right side of this equal sign, which is going to be this entire function. So add is now essentially our add function. So we can say add like this, we can run it and we get 15. Now there is one small difference between doing this and defining functions like this. So for example, what if I was to take this function and move it to the bottom here? So let's paste it down here, run it, and we still get 15. So we can actually call a function here before it's defined here. So the order doesn't necessarily matter. However, with variables, it does matter. So when we create a variable with let, we cannot actually use the value of that variable until we've created it. So if I was to take this add function and move it to the bottom here, well, now we are using add here, but add isn't defined until down here. So if I run this, we actually get an error, cannot access add before initialization. So typically I don't tend to ever really use this syntax of using anonymous functions at the top level with a name. I just don't think it necessarily makes sense. However, anonymous functions as callback functions can make sense from time to time, and it can just be a useful tool to have. Next, I want to look at something known as an arrow function, which is an alternative to the anonymous function syntax that we just saw. So we have the same calculate function. It takes an a and b and some operation as a callback and returns a and b passed in to that operation. And then right here, we are logging out calculate with 5 and 10 and this function here, which is essentially just an add function. So we end up getting 15. Now, this works, but you might be thinking, this is just sort of a lot of code. There's a lot happening here. So one option instead of all of this is to remove the function keyword, and then after the parentheses for the arguments, we're going to add in an equal sign and then a greater than sign. So this is an arrow. Sometimes we call it a fat arrow. And now if I run this, we get the same thing. So this is actually a function right here. So just to show you this sort of outside of this console log, this is that arrow function right here. But we can actually take this one step further. So I'm going to remove this. And that's that arrow functions have a lot of shorthand syntax built into them. And one piece of that is that if the arrow function only has one line of code, and that one line of code has a return statement in it. So if all we're doing is returning something, we can actually omit the return keyword and omit the curly braces. So what I'm going to do is get rid of return and the curly brace, and then I'll also get rid of the curly brace here. And then we also need to remove the semicolon. So if you use this shorthand syntax, you cannot have the semicolon. Now, if I run this, you'll see again, we get 15. So now this version of the arrow function is the exact same as the previous arrow function we just saw. And a lot of people really like this because it is so concise. So whenever you're using callback functions, you only need the callback one time and there's no reason to define it at the top level. You can use these arrow functions with this very concise syntax to just make the code look much cleaner. And now 2 things to note. So first of all, we can still give these names. So we could do something like say let add equal this arrow function, and typically we do add a semicolon at the end here. So this is going to be our add function, and we could pass it in like this if we wanted to, and we still get 15. And one other cool point with arrow functions is if you actually only have one parameter, you don't even need the parentheses. So if say all this takes is one number, and then it does something like say number plus 5. Well, now all we need is the one parameter name and then the arrow, and that is the whole function. So we can run this and you can see we actually still get 10. This is a little bit confusing because this calculate function expects that operation is going to have an A and a B, whereas this operation actually only takes A. So B is just not actually being used, and we end up saying A, which becomes num plus 5, so we're passing in 5, and we get 5 plus 5, and that gives us that value of 10. And of course, we could do this inline as well, so we could take this and put it inline, and we still get 10. And lastly, we can also, if we have no parameters, just do empty parentheses. So if there are no parameters, we can't do nothing here because it just is not valid syntax, but we can do just empty parentheses, and maybe this always returns 20 plus 5, and let's use the add function like this, and we get 25. So essentially, from a very high level, an arrow function is going to be this syntax here. And then you'd have some code in here, and you can have as much code as you want there. However, if the code inside of the arrow function is one line and you need it to return, you can simply do something like this, and then whatever you want to return. So for example, this is a function that always just returns the value of 5. And then finally, if you have an arrow function that takes in a single parameter, you can have that parameter and then the arrow without the parentheses, and then maybe this one returns num plus 5. So essentially, these are all just different ways to define functions in sort of a modern, concise syntax. It is worth noting that there are some very small differences with how arrow functions actually work, such as with the this keyword, which is something we will see later on in this course. But for now, just know that they work almost the exact same in the vast majority of circumstances. So most of the time, if you have a callback function and you're doing it inline, arrow functions are probably the way to go. And you'll also actually see some people who just prefer using arrow functions all of the time for all of their functions. So even at the top level, they'll do something like let calculate equal and then make this an arrow function. And that is fine. Personally, I don't really prefer this syntax. I don't really understand the purpose of doing it this way, but some people do prefer this. So I just wanted to show you this as it is something you will see in some code bases. Next, I want to talk about something known as an object, which is essentially the opposite of a primitive. So we've seen primitive values like numbers and strings and Booleans, which are sort of the basic building block values in JavaScript. However, we also have object values. So objects are essentially a combination of primitives. So for example, here we have a name of Connor and an age of 26. And you can think about these two things as being related, right? These both have to do with one person. This is the name and this is the age of that person. So it makes sense to find a way to group these together, especially if, say, we had multiple people and we needed to distinguish which name goes with which person and which age goes with which person. It becomes sort of complicated. And the way we can handle this is by using objects. So we can create an object just like any other variable. So for example, let's say let person, and we're going to set this equal to curly braces. So just like we use curly braces for code blocks, we also use curly braces for objects. And essentially, this is going to be a key value store. So we have keys that are sort of like variable names, and then we have values that are sort of like the values of those variables. So for example, we can say we have a name, and then we're going to use a colon, and then whatever the value is. So in this case, the string of Connor, and then we'll also have an age, and you can notice we have a comma between these. So we'll have the age, the colon, and then 26. So a few things to note here. First of all, we don't need to put the keys in quotation marks, although we could if we wanted to. This is perfectly valid as well. Most of the time, though, you see it without quotation marks, but these are essentially strings. Technically, there are some other ways that the keys can be defined, but the vast majority of the time, they're going to be strings, and you don't need the quotation marks around them. Then we'll have the colon, and then the values, which can be any type. So we can come down here. Let's say console.log our person, and you can see we get this object in the console. So we have the name of Connor and the age of 26, and this is all sort of one contained value. And now we can also get the values out of the object. So instead of saying console.log person, let's use console.log person.name, for example. So this dot is going to get some property. So we call these our property values or the keys. So person is here, and then dot says go into the person and find the name. So person.name is going to give me Connor. Person.age, of course, would give me 26. And if you do something that is not there, so for example, person.birthday, this is just going to give you undefined. So if you ever try to get a property that doesn't exist, you get undefined. Let's go back to person.age. Now, in addition to what we call dot notation, which is what this person.age is, there's also one other way to get the values out of objects, and that is using bracket notation. So instead of a dot, we're going to open up brackets, and then we're going to make this be a string. So now person brackets string age is going to be 26. And now it is important in this case that you actually include the quotation marks. We could also do person bracket the string of name, and that is also going to give you Connor. And this can be useful for a few reasons. For example, if we have these property names or these keys being dynamically generated in some way, you can actually use a variable here. So for example, we could say let key equal name, and then we could do person and then brackets and our key. And remember, this is a variable, so it represents the string of name, so we still get Connor. There's also another edge case for this, so I'm going to delete some of this just to clean things up. And that is if we have a key that has a very specific format for a name. So what if instead of name, we wanted to say we have a first name? And typically we're going to do camel casing, which is what this is. This is what we've been doing throughout this course whenever we have multiple words in some variable name, where the first letter of the first word is going to be lowercase, then everything else is lowercase, but then the start of any new word is uppercase. However, if for some reason you want to use dash naming instead, so if we did first dash name, this actually isn't going to work. And the reason this doesn't work is because JavaScript doesn't really know what to do with this. It's like, hey, is this supposed to be subtraction? And it essentially just creates invalid syntax. So what we can do instead is we can put this in quotation marks. And now this is actually a valid property name. However, if we tried to do person.firstName, well, now we're doing person.first minus name. So this is subtraction. And that's not good. That's not what we wanted. So it isn't actually going to work. So instead, what we can do is we can use the bracket notation, and we can put this in quotes. And that would actually work, so we would get Connor. So essentially just note, if you happen to have a dash in the object's name, you're going to need to use quotes to define it, and you'll need to use the bracket notation to actually get that value. However, the vast majority of the time, my recommendation would just be avoid having dashes in names. Really, this is just something to know in the case where you happen to get an object from somewhere else that you don't control and it has a dash in it. This is going to be how you can get that value off of it. But most of the time, we don't want to have dashes, and we'll just be using dot notation. So for example, person.age. Next, we're going to look at what's known as a method. And all a method is simply a function that is on an object. So simply put, methods are functions that are values within objects. So for example, here we have our person, and we can add a method in a few different ways. So one is in the same way that we've been adding values to our object. So we could do something like say hello, and we could set this equal to an anonymous function. And let's say this simply says console.log hello. And now what we could do is we could call person.sayHello, and this is going to log out hello. Now this does work, however, there is a built-in syntax for this. So instead of using the function keyword, we will get rid of this and get rid of the colon. And this is going to do essentially the same thing, so we still log out hello. And we can also within our method use the other values from our object. So let's get rid of this and instead have it be a template literal that's going to say, hello, my name is, and then we want to include our name, which is the first name. So we're going to say this. So the this keyword refers to the object we're currently on. So we're going to do this dot first name, and we can run this and we get, hello, my name is Connor. Now the this keyword is something that's a bit new here. And like I said, this is going to refer to the object that we are currently on. That said, there are a lot of different scenarios where the this keyword actually comes up within JavaScript. So it can mean different things in different circumstances. But within an object in one of our methods, it's going to refer to that object. However, there is one caveat here. So if instead of using the method syntax, we instead had a function like this, it's still going to do the same thing. But if we used an arrow function, so if instead of this function, we used an arrow function, our this.firstName is actually going to end up being undefined. So the point of this video right now is to focus on methods rather than focusing on all of the intricacies of the this keyword, but just know if you need to use this within a method, you'll want to use the actual method syntax or an anonymous function. You will not want to use an arrow function because it simply will not work. So we'll go like this instead, and that will work. And we can also use a method as a way to update our object. So let's add another method, and let's say have a birthday. And what this is going to do is it is going to take our age. So we're going to say this.age plus plus. So it's going to increment our age. So now let's say have a birthday, and then we can do console.log person.age, and you'll see we get 27 because our age is initially 26, and then we had a birthday, so it becomes 27. And of course, if we logged out age before have a birthday, we would get 26, and then we get 27 after. And if, say, we have 2 birthdays, we would end up getting 28. Now, I also want to look at what happens if we have 2 different objects and they share a method. So what I'm going to do is simplify our object a little bit to simply our first name and say hello. But I'm going to take the say hello function, and I'm actually going to move it off of the object. So we're going to say hello is our say hello function, and we'll define that up here. So let's say function say hello, and then we can paste all of this in. And now we have our say hello function that does the same thing as before. And now just as a small note, when you have a property name and the value that are the exact same, you can actually just include it like this. So this is sort of a shorthand for what we just had. So now we have say hello is on the person. And let's add one more person down below here. So I'll get rid of all of this. Let's say we have person 2, and let's make this one's name Grace. So now both of these have the same say hello function. However, the say hello function is going to do a different thing for person 1 versus person 2 because we use the this keyword, and the this keyword refers to whichever object we're currently on. So for example, if we say person.sayHello, we are going to get hello, my name is Connor. And if we instead did person2.sayHello, we get hello, my name is Grace. So hopefully that gives a little bit of an idea of why the this keyword is actually going to become useful over time. I also wanted to mention that we've actually been using object methods this entire time. The console log function we've been seeing is actually itself a method. So console is simply an object that is given to us by JavaScript, and log is a method on that object. So this entire time, every time we've been doing console log, we are getting an object, calling a method on that object, and then passing in some parameters to it. Next, we're going to look at a few different ways that we can check for the existence of some property or key within an object. So here we have this object person with a name and an age. And first we use an if check for if the person.name is not null. And if it's not null, we log this out. We can see we do get that log here because person.name is not null. But if, say, we commented this out, well, because we're doing loose equality, this is also going to be checking for undefined. So we do not log anything out here because person.name is undefined. So this is sort of the first way that we can check for the existence of something in an object. But there's a few things to note here. First of all, what would happen if, say, instead of having this commented out, we actually just explicitly had it set to null? Well, in this case, we still don't get into this if check because it's just saying is person.name null, and it is, so we don't get into the if check. Same thing if this was undefined. We do not get into this if check because name is undefined. So even though name is on this person object, the value is undefined. So this is checking that value against null. Additionally, we actually aren't just looking at the properties on this object. So we're not going to go too in depth on how all of this works in this video right now. However, just know that objects actually inherit some properties from other objects. So all objects have some special properties. For example, there's a toString method. So if we said person.toString, well, we don't see toString here. However, we actually get into the if check. And why is that? It's because every single object has a method called toString by default. So because this exists, we actually get into here. And at times this might be the behavior you want, but oftentimes it's not. So we do have a few different ways that we can check if a property exists. So first, I want to look at an operator known as the in operator. So instead of this check against null, what we're going to do is first of all have our property name as a string. So for example, name, and then we're going to have the in operator, which is just the word in, and then the name of our object, so our person. So this says, is name in person? If it is, log out this, and if it's not, of course, don't get into the if check. So if I run this, we can see we do log this out, even though name is set to undefined. So this is checking, does the key actually exist? Is this property there? Do we have it on the object, regardless of what the value is? So if this is null, we would also get the same thing, as well as if this was some actual value, we still get the same thing. That's worth noting that within we have the same quirk that we had when we were just doing a check against null. And that's that if we add some different property here that is on all objects and it's inherited, but it's not actually explicitly on our person object, it is still going to have the result of being in that object. So if, say, we do toString here, you'd see we do get in to this log. Now, if we had something here that's not on this person, of course, we don't get into it, but just know again, if you accidentally check for something that is an inherited property, that you could end up getting a bit of a weird outcome. So because this in keyword can be a bit strange and doesn't always do what you expect, there is another way we can do this as well, and that is a method known as hasOwnProperty. So this is actually one of those things that is inherited on all objects. So we can see this object doesn't look like it has any methods. But if we do hasOwnProperty is in person, you can see we do actually have something called hasOwnProperty, and that happens to be a method. So let's try using it. So we can say if person.hasOwnProperty, and then it's going to take in the property name. So for example, in this case, we have name, then you see we get into this if check. So this checks, do we have whatever this key is on our object? And with this one, again, if you have, say, null or undefined here, it is still going to say that, yes, we do have this key. However, if we went back here and we did something like toString, you can see we don't get into the if check. So hasOwnProperty, as the name suggests, it checks for own properties, meaning properties that are explicitly on this object here, not anything that's being inherited, such as the hasOwnProperty method itself or the toString method. So most of the time, hasOwnProperty is what you tend to see. However, there are some small edge cases that it actually doesn't cover either. For example, what if our object had some hasOwnProperty method itself? So let's just say that this, for now, is just an empty method, but you could imagine it is some method we've implemented and we needed on our person object. And then we want to check, do we have hasOwnProperty? So hasOwnProperty. So what's going to happen here? Well, we do person.hasOwnProperty, but person.hasOwnProperty is no longer that hasOwnProperty that we had on all objects because we've overridden it. We have this. So it's going to call this function. So that's not going to do anything with this parameter, and it's not actually checking if we have it. So because of this, nothing's going to happen. We aren't outputting anything, even though we do have a hasOwnProperty method. And I know this is a very odd and specific use case, but I did just want to show it because it is sort of the motivation for why we have a replacement for hasOwnProperty. So instead of hasOwnProperty, what we're going to do is say object. So object with a capital O is actually an object that is given to us by JavaScript. and this has a hasOwn method on it. So we're going to call object.hasOwn, and we're going to pass in our object and then whatever the property name is, such as name, and you can see we get into here. But we can also do hasOwn property, and you can see we also check that, okay, it does have a hasOwn property, but if we commented this out, we would no longer have a hasOwn property because it is checking, does this object have this as an own property, so actually defined here, and it doesn't. So generally speaking, object.hasOwn is considered to be the replacement for the hasOwn property method, just because of this small edge case and a few other very specific small edge cases that realistically you'll probably never actually run into, but this is the way that we're sort of moving forward with the language. That said, at least at the time that I'm recording this video, we're sort of just now getting to the point where every browser is supporting object.hasOwn instead of hasOwn property. So you will still see both being used. So it's good to know that they both do effectively the same thing in 99.9% of circumstances. And as far as the in operator and explicitly checking against null and undefined, most of the time that's not actually going to be what you want to do. But of course, there might be some circumstance where that behavior we saw is what you actually want, in which case it is fine to use those methods as well. Next, I want to look at how we can nest objects inside of each other. So here we have our person again with a name, age, and now an address. And the address is this string here. But this string as an address is probably actually not that useful. And why is that? Well, if we're doing something programmatically with this address, we're going to need to somehow take this and sort of break it up, right? Like, what if we wanted to know what state are they in? Well, that's this part at the end. Well, what if we wanted to know what street they're on? Well, that's this part here, and it's just sort of all a jumbled mess. So instead of having this whole string, and I'll just put this down here and comment it out so we can see it, what we're going to do instead is make the value of our address be another object. So we can just open curly braces again, because the values in our objects can be any type, including more objects. So we have another object now that is nested inside. And then we can say we want something like our street address, which is going to be the 123 main street portion. And then we can say we want a city, which is going to be Palo Alto. And then we also want the state, which is going to be California, or we had it abbreviated as CA. So I'll just leave it like that. And now we could actually get these values. So we could do something like console.log, our person.address, and you'll see that this is actually just going to be that entire object. But we could go further. So this here returns an object. So how do we get some value out of the object? Well, we can use the same dot notation. So for example, person.address.city is going to give us Palo Alto. But we could even go one step further. So we have our street address, and this has the number as well as the street. So maybe we want this to be an object as well. So we could say our street address is going to be another nested object. And we could say we have our number, which was 123. And then we also have the street itself, which was Main Street. And now with our console log, let's come down here and say log out person.address.street address. And this is going to give us now this object. And then we could say maybe we want just the name of the street, and that is going to give us Main Street. And now as you're sort of designing your objects, you want to be careful about not overly nesting. For example, here, maybe this is a bit overkill, and maybe we shouldn't have this nesting here, and we could just do something like this, where we just have our number and our street like this, and then we could do something like that, and that would also work. So you'll just want to be careful about not overdoing it, because it can tend to make the object and just our code in general less readable when you have a bunch of very deep nesting. But oftentimes it will just be personal preference of how exactly you want to design the particular object that you're currently working with. Now we've seen in JavaScript a few different objects that were given by default. For example, we've been using the console object to log to the console throughout this entire course. But one object that we actually end up using a lot is going to be the math object, so I wanted to look more closely at it. So let's say console.log, and first of all, we're going to look at math.random, which we actually saw a little bit earlier, very briefly. So we can say math.random we can call this function, and we'll see it's going to log out a random number. And specifically, this is going to be a random number between 0 and 1, with 0 being inclusive and 1 being exclusive. So if I run this function a few more times, you'll see we keep logging out different numbers in that range. Now, one caveat here is this is what's called a pseudo-random number, so it's not actually purely random. It is as random as you'll need in the vast majority of circumstances. However, the one caveat there is you should not use this for something security related like cryptography, because it is not actually purely random, and thus it's going to be inherently insecure in most of those circumstances. Another thing we end up doing a lot is when we have some number, oftentimes we want to round that number. So we have a few different ways to round. One is going to be the round function, which is going to take in some number. So for example, if we had 20, we of course just get 20. But if we had 20.5, it's going to round that up to 21. But if we had 20.4, it rounds down to 20. So this works just like you've probably seen rounding in traditional mathematics. It is going to round to the nearest integer. And this will work for negative values as well. So negative 20.4 gives us negative 20, negative 20.5 also gives us negative 20, and negative 20.6 gives us negative 21. So if we have a 0.5, it's going to go to the higher number, and that works with negatives as well. So the higher here is negative 20, and the lower is negative 21. So it's not the higher absolute value, it is the actual higher number. Now, of course, this works, but sometimes we do want to always round down or always round up. And for that, we have two different functions. So first of all, we have ceil for ceiling. This is going to always round up. So negative 20.5 is going to round up to negative 20, negative 20.6 also gives us negative 20, same thing with negative 20.4. And if we go to positive 20.4, we get 21, same thing with positive 20.5 and positive 20.6. So it does not matter what that decimal is, even if it was 0.0001, we would still round up to 21. However, if we have 20 here, we do not round up, we just get that value. Likewise, we also have a floor function. So floor is going to always round down. So here we have 20, and if we say 20.5, we round down to 20. If we do 20.4, same thing. Even 20.99 is going to round down to 20. And this, of course, also works with negatives. So negative 20.99 is going to give us negative 21, so it's rounding down. And if we had negative 20.01, we still get negative 21. So again, rounding down. Now, one interesting use case of the math.random and math.floor functions together is finding a random integer. So what we can do is come down here and say function, and let's say get random integer. And let's have it take in some max value. And what we're going to do here is get a random integer between 0 and that maximum value. So, okay, how can we do that? Well, first let's say return math.random because we know we need a random value. But we know math.random just gives us a random value between 0 and 1. And we don't want a random value between 0 and 1. We want a random value between 0 and this maximum. Okay, so let's multiply by our maximum. So now we have a random number between 0 still, because 0 times our max is still 0, and our maximum number, because say the maximum number was 15, and the maximum here is 1 exclusive, so that also means that the highest value we get here is 15 exclusive, because 15 as our max times just less than 1 is always going to be just less than 15. But now this is actually giving us a decimal. So if I was to actually call this, so let's come up here and call get random integer and say, let's pass in the number of 15. You'll see we get a number between 0 and 15. However, these are still decimals and we wanted an integer. So how can we get an integer? Well, we can use one of our rounding functions. It just so happens to be that math.floor is going to be the function we most likely want. So if I run this again, you'll see now we're getting these random integers between 0 and 15. And specifically because we're using math.floor, meaning we're rounding down, what's actually going to happen is if math.random times our maximum gives us a value between 0 and 1, excluding 1, we're going to get 0. And if it gives us 1 till 1.999, we're going to get 1, and that's going to go all the way until 15. It's actually going to give us equal likelihood of these numbers from 0 to 14. Again, with 15 being exclusive because math.random will never actually give us the number 1. But okay, let's remove this function and let's look at a few different other math functions that we have access to. So let's remove this function call as well. And the next thing I wanted to look at is something known as math.abs, or the absolute value function, which is going to give us the absolute value. And if you remember from math, if we have, say, 15, that's going to be 15, and negative 15 is also 15. So all it does is it takes the value we pass in and removes the negative sign if there's one. And if, say, we had a decimal here, so 15.2, we still get 15.2. So it removes this negative sign, but it does not remove the decimal. So we get the exact same number, just without a negative. I also wanted to look at something known as math.min, which is going to take in some values. So for example, if I just give it the value 5, it's going to return 5. But we can give it multiple values. So we can say 5 and 10, and we still get 5. But if I added, say, 4, we now get 4. So this takes in as many numbers as you want to give it, and it returns to you the lowest number. Likewise, we also have a max function. So math.max is going to give us the highest number. And of course, these can take in negatives as well. So if we made this negative 10, now the maximum is actually 5. However, the minimum is going to be negative 10. And now I'm not going to go through every single function on this math object because there's actually a lot of them to do a lot of different things. For example, there's a bunch of them for doing sine, cosine, tangent, and all of those trigonometry functions. So just a ton of different functions on the math object. But I just wanted to show you some of the most common ones that you tend to use. And just know that if you need to do some math related thing, there's a good chance that a function exists for it on this math object. So that'll be a good first place to look in the documentation if you need to do some more obscure mathematics in your code. Another object I want to look at is the string object, which actually works a little bit differently than most other objects in JavaScript. It's sort of a special case of objects. So we know that strings, like this hello world string, are primitives. However, in JavaScript, there's actually wrapper objects for primitives. So for example, for numbers, we have a number object that we can use. There's also, with strings, the string object that we can use. But what's special about strings is that if we have a string primitive, we can actually use the object properties on that primitive, and JavaScript is just going to automatically say, oh, they're trying to use the object. Let's convert this string primitive into a string object, and then allow them to use it, and then convert it back into a primitive, essentially. And this process of being able to take a primitive and use it as an object is oftentimes referred to as boxing. And then the process of taking that object and using it again as a primitive is known as unboxing the primitive. So for example, we here can say constant.log str.length. So length is a property of that string object, and this is going to give us 11. So it just counts the number of characters in our string. Although one very small caveat with string.length to mention is that the vast majority of the time it does what I just said, it counts the number of characters. However, there are some edge cases. For example, if I add a smiley face here, you'll see I added a space and a smiley face. So this should be 2 more characters, we should get 13. However, when I run this, we actually get 14. So this emoji actually counted as 2 characters. And the reason for this is it's not actually counting the number of characters, it's counting something known as code units, which essentially have to do with the underlying implementation of how strings are actually stored in JavaScript. And even more specifically, it has to do with Unicode, which is the encoding format that JavaScript actually uses, and how it handles more obscure characters. And I'm not going to go into all of the details of how Unicode works, but just know if you're using characters you regularly see in languages like English, it's not going to be an issue, it's just counting characters. However, if you start adding emojis or some more very obscure characters, then you might end up with some edge cases where string.length is not actually going to be the number of characters in that string, so it's just something to be aware of. But okay, with that aside, let's take a look at a few other properties we get with strings. So instead of length, one other useful one to use is going to be 2 lowercase as well as 2 uppercase. So this is actually a method that is going to convert the string into a lowercase string. So you can see now we get hello world in lowercase. Now it is worth noting that with 2 lowercase, as well as we also have 2 uppercase, so this is going to make everything uppercase, these are not destructive. And what I mean by that is that they actually return a new string. So the original string is going to be unchanged. So if after doing 2 uppercase, we just log out our string again, you'll see it is the same as it was before. So this is not changing the string, it is giving us a new string where everything is uppercase. Another method that can be useful, especially if you're dealing with user inputs, is going to be the trim method. So trim is going to remove whitespace on the edges, so at the end and at the beginning. And this can be helpful because if you have user input and they type into some box on some website, oftentimes they'll accidentally add a space at the beginning or the end, and you usually don't actually need that. So what we can do is to trim these values. You'll see if I run this, we get hello world here without the extra spaces. And again, this is not going to be destructive, meaning if we log out string again, we still get the version that has the extra spaces down here. And also sometimes you might want to trim only the beginning or only the end. So for that, we have trim start, which is going to trim just the beginning. So we can see we have hello world here, but there's actually still extra space at the end. And then we also have trim end. So this is going to trim the end. So there's no extra space at the end here, but we still have these extra spaces at the beginning. Now I'm going to put this string back. And another thing that can be pretty useful is to find different elements within our string. So either to find characters or to check if some character exists in our string. So the first version of this is going to be the includes method. And this is going to take in some string. So for example, maybe we just want to see, is there a letter O in our string? And this is going to return to us a Boolean, true if it was there, false if it was not. But if, say, I did the letter A, this is going to be false because there is no A in the string. And we could do something like maybe EL, and this is going to be true because we have EL here. But if I did, say, EO, this is false. So we do have an E and we have an O, but it's looking for this exact string somewhere inside of the string, and that does not occur because there's other letters in between the E and the O. Now you might also want to know where exactly it found whatever letters you were looking for, and for that we can use index of. So this works the same way, except it's going to tell us where the first location of that value was. So if I do the string of E, we're going to get 1. So it starts at 0, so H is 0, and then you can see this E is 1. And if I did something like, say, O, we are actually going to get 4. So we have 0, 1, 2, 3, and then 4. So that's going to be the O at the end of hello. And this is the case even though we have another O here. So it's just looking for the first index of this string we pass in. And just like includes, we can also have longer strings here. So for example, LO is going to give us 3. So we have 0, 1, 2, 3. So the string of LO starts right here at the end of hello, and that is at index number 3. Additionally, if we add something here that is not in the string, like the string of A, we're going to get -1. And you'll see this is a pretty common pattern of JavaScript functions, especially ones that return numbers, is if they don't find what you're looking for, they will return -1 as sort of a we couldn't find it value. It's also worth noting that there's a version of this that is last index of. We don't tend to use this too often, but if you don't need the first index, but instead need the last one, then we could do O like this, and you can see we get 7, which is this O in world. So it does the same thing as index of, but it starts at the end and looks backwards for the first instance. And again, we could do something that involves multiple letters here. So if we go back to LO, we'd still get 3 because that is right here. And you'll notice that even though we're going from the end, the index it returns still counts from the beginning. So we still get 3. So that is the third index counting from the left, even though last index of is looking from the right. Now, sometimes you want to check to see if a string starts with something or ends with something. And for that, we have the starts with and ends with functions. So we can say starts with, and we could say maybe the capital H, and we would get true. It is worth noting that these are case sensitive. So if I did a lowercase h, this is false because the string does not start with a lowercase h. And this is true for all of these functions we've seen. They're going to be case sensitive. And again, this can take in multiple letters if we want. So HE is going to be true. And then there's also an ends with function. So instead of starts with, let's do ends with, and HE is going to be false, but say D is going to be true. And same thing with LD would also be true. And now I'm not going to look at every single property of the string object in this video just because there are a ton of them. And frankly, we don't use most of them all that often, but hopefully this does show you some of the more common ones that we do tend to use. And if you do need something for a string that wasn't shown in this video, a good first place to start would be to look at the string documentation to see if a method already exists for that, and oftentimes you might find that it actually does. Next, we're going to be looking at something known as an array. And an array is simply a way that we can contain a list of values. So here we have 3 different students. Student 1 set to Ada, student 2 set to Grace, and student 3 set to Alan. And this should already be a bit of something known as a code smell. So something that you look at and it just doesn't feel quite right. It should give you the idea that maybe there's a better way to do this. And specifically what I'm talking about is this numbering. So having number 1, number 2, number 3 just feels like there should be a better way to do this. And in fact, there is. So the way we can create what's called an array is the same way we can create any variable. So let's say let students this time, and we'll set this equal to brackets. So we will use the curly braces for objects, and we will use brackets for an array. And then inside of the brackets, we can simply put any values we want. So for example, we can have Ada, we can have Grace, and we could have Alan. And now this students array is going to essentially be just like this, but instead of having student 1, 2, and 3, we can simply use the first 3 values of this array. So let's come down here and say console.log, and first let's just log out our entire students array, and you can see we get that array down here. And now if we want to get a value out of the array, we can use bracket notation, and this is very similar to the notation we saw with objects. So we had the dot notation as well as the bracket notation to get values out of objects. We can do the same thing with arrays, although we'll always use the bracket notation, and we'll pass in a number. So this is going to be 0-based indexing, meaning the first value is at index 0, then index 1, and index 2. So for example, if we say students at 0, this is going to be Ada, students at 1 will be Grace, students at 2 will be Alan, and if we went all the way to students at 3, well now we simply get undefined because we do not have a third value in the students. And we can also use this syntax to actually update values. So for example, I could say students at 1 is going to now be Connor, and then I could come down here and log out students at 1 and you'll see it's Connor, or we could log out all of students and you'll see we have Ada, Connor, and Alan. So this just overwrote the index 1 value in students, so we no longer have Grace and instead have Connor. We can also use arrays for other values. So for example, I could add a value of some completely different type, so maybe just the number 20 here. We can run this and you can see we now have an array with these 3 strings and the number 20 at the end. And we can really have any types we want here. So any type we've seen, we could even have something like a Boolean, we could have something like null, or even undefined in our array, and it will actually be there. And as you're seeing here, JavaScript does not restrict our ability to actually mix types in the array. So for example, here we have undefined and some strings, although most of the time we'll want to stick to a single type, simply because it usually doesn't make much sense to have multiple types in the same array, because the array should represent one sort of list of things, and having multiple different types means it's sort of representing multiple different things, which probably doesn't make a lot of sense. It's going to make it harder to use the array because you'll have to check what type everything is before you use any element of that array. Next, I want to look at what sometimes we call nesting arrays, or 2-dimensional arrays, or multi-dimensional arrays. And that is simply the ability to have arrays within arrays. So we said inside of arrays, we can have values of any type. And that's not just primitive types. We can also have other arrays or even objects inside of our arrays. So for example, here we're trying to make a matrix. So a matrix from mathematics is essentially a 2D grid of numbers. So the way we can do this is say, okay, inside of our array, let's have another array. So the first element in the main array is another array. And let's say this has the values of 1, 2, and 3 in it. And then after that, we will have maybe 4, 5, and 6. And you'll see if I run this, we now have this 2D array. So we're logging out our matrix, and the first element in the main array is another array with the values 1, 2, and 3, and the second element is another array with the values of 4, 5, and 6. And if, say, we were to log out matrix at 0, well, this is going to give us the first array of 1, 2, 3. And if we wanted to get, say, just this value, well, that is matrix at 0, so this array, and it is value 1 inside of that array. So we'll use the bracket notation again. So this is row at index 0 and the first column. So that is going to give us this value of 2. I also wanted to briefly mention that we can combine objects and arrays. So for example, I could do something like let obj equal, and let's set this equal to an object. Let's say we have a matrix inside of our obj, and we can copy this right here. And now we could come here and say, log out the obj, and we have that whole object, and we could do obj.matrix is our 2D array, and maybe obj.matrix at 1 at 2, and that's going to give us that value of 6. So we go to the object, we get the matrix property, which is this array, we get index 1, which is this array, and then we get index 2, which is this value of 6. And you'll see that if we really wanted to, we could even nest even further, so we could have another array inside of here with, say, the value of 7, and let's get rid of that, and you'll see now we have another nested array inside of this nested array. So it can go as deep as we want. And we could also nest objects inside of objects, so we could have, let's say, nested obj is going to be an object, and maybe we put the matrix inside of this nested obj. Now we'd have obj.nested obj.matrix, and that would give us our matrix. Of course, this example is a little bit contrived. There's not really any reason to have this matrix inside of these objects, but there are many circumstances that we'll run into where it is actually going to be useful to have arrays inside of objects or objects inside of arrays, or really any other permutation of this nesting of arrays and objects. Next, I'm going to look at some different ways that we can add and remove elements from an array. So the first is sort of the most basic, but one I actually would never recommend you do, and that is simply to do something like, say, nums at 3 is going to be equal to 10. So 3 is the first index we don't currently have, so we have index 0, 1, and 2, and this would actually add 10 to the end of the array. However, I would almost never recommend doing it this way, and instead, what you should do is you should use methods of the array. So arrays are actually technically objects in JavaScript, and what this means is that they have some methods. And the first one of these is going to be push. So we can say nums.push and then pass in whatever value we want to add to the end, such as our value of 10. You can see this adds 10 to the end. We can actually also pass in multiple arguments if we want. So maybe we also want 100, and that adds 100 to the end as well. Now there's also sort of an opposite to push. So let's, instead of this, say we're going to pop. And what pop does is it removes one element from the end of the array. So now we have just 5 and 8. It's also worth noting that pop is going to return to us that value. So if we did something like console.log nums.pop, you'll see it actually logs out that value that was removed. So this is -20. And now similar to pop, if we want to go from the beginning, we also have a function called shift. So this is going to remove the first element. So you can see now we log out 5 and we have 8 and -20 left in our array. And similar to push, we also have a function nums.unshift, which is going to add to the beginning. So maybe we do 10, we can see that now we have 10 at the beginning of the array. And of course, we can combine these together. So we could also do something like, say, nums.push 100, and you'll see we get 10 at the beginning and 100 at the end. Now, one small note here is that push and pop are actually going to be far more performant functions than shift and unshift. And that might not fully make sense, but to try to explain why this happens, let's think about what these actually do. So with push, it says, okay, take this array and just add one element to the end of it. So we can see we're pushing 100, so that means just do that. And that feels pretty simple, right? All we did was add an element to the end. However, with unshift, we're adding an element to the beginning. And this might feel like, okay, all I have to do is say 10 comma, and then that puts everything there. But if we think about how this is sort of actually stored within JavaScript, we have this set of values and say 5 is at index 0, 8 is at index 1, and -20 is at index 2. But when we unshift, so when we add 10 to the beginning, we're actually moving all of these values. Every single one of them has to move up one space in the array. So with push, all we're doing is putting something at the end, and nothing else actually moves. But with unshift, we have to move everything in the array, and because of that, unshift is actually going to be far less performant than push. And the same is true with shift versus pop. So if we were to pop an element off, all we do is remove this last element. However, if we shift an element off, we remove the first element, but everything else needs to shift over one. So for example, here, 5 has to become index 0. So the key point is simply that arrays in JavaScript can change in size, first of all, because in some languages, if you have coded in other languages, you might have seen arrays that have a constant size. That's not the case in JavaScript. Their size can actually change. And we have 4 main methods for doing this: push and pop to add and remove from the end, and unshift and shift to add and remove from the beginning. However, push and pop are going to be far more performant than unshift and shift, so you'll want to use those when you can. Next, I want to look at how we can actually iterate through the values in an array. So we know an array is an ordered data structure, meaning that all of the elements have an index and they are always going to be in the same order. So we can iterate through those elements in order using a loop. And traditionally, we're going to use a for loop for this. So let's create a for loop, and we can say let I equals 0. So I is going to be our index, which is going to be essentially the current index in that array. And we can say, while I is less than, and we need to get the last index of the array. So we want to go until we get to the end of the array. So we're going to say nums.length. So length is a property that all arrays have. So remember, arrays are objects, so they can have some properties. And one of those is going to be a length property. And most of the time, this is just going to be the number of elements in the array. So in this case, we have a length of 3. And then we're going to say in each iteration, we want to increment I. So we can say I plus plus. And now we can say console.log, and let's log out the current element. So we can say nums at I, because again, I is going to be our current index in our nums array. And if we run this, you can see we get 5, 8, and then -20. So that's really all there is to iterating through arrays with a traditional for loop. Now, there is one other way we can do this, and that is to, instead of using this traditional for loop syntax, what we're going to do is say for, and we'll say let num, and then we'll use the of keyword nums. So essentially what this is going to do is it's going to iterate through our nums. So we're going through nums, and we're going to get each value in nums and save it in this num variable. And we can log out num, and you'll see we get the same result. Now, personally, I don't use the for of loop too often, but it is something that's nice to know about, and it can just be a nice, concise syntax. Next, I want to look at a few more ways that we can iterate through an array, this time using functional iteration, meaning we're going to use functions or methods that come on the array to actually iterate through them. So the way we can do this is to come down here, and we can say nums, and the first one of these is going to be the for each functions. We can say nums.forEach, and this is actually going to take in a callback function. And this callback function is going to get some parameters, and that is going to be the current value. So let's say that this is going to be our num, and let's open up this callback function. And now we have inside of this callback function each number. So we're going to call this callback function one time for each value in this array. So for example, we could say console.log our num. We could run this, and you can see we get 5, 8, and -20. Now, in addition to our number, we could also have another value here, and that is going to be our current index. So let's also log out the index, and we can see we have 5 at index 0, 8 at index 1, and -20 at index 2. Additionally, if we do need it, which usually we don't, but if you do need it, you can also get the original array as well. So let's just call this ARR. And let's log that out as well. And you can see that is going to be that original array that we are actually iterating through. So it's going to be the same as this value here. But okay, let's put this back to just our num. And we can do the same here. And now what I want to show is instead of for each, let's use the map function. And this is at the very surface level going to do the same thing. So we can run this, and we can see we still get 5, 8, and -20. But what map does is it actually returns a new array with whatever values we return in this function. So instead of console.logging num, what I'm going to do is say return maybe num times 2. And now what we're going to get is a new array. So let's say let new array equal nums.map. And let's come down here and say console.log our new array. And when I do this, you'll see we get a new array with all of these values multiplied by 2. So now we have 10, 16, and -40. It's worth noting that this is a completely new array, so it does not change nums. So if I come up here and log out nums, we'll see it is unchanged. So we still have 5, 8, and -20 for nums, so the same values we had here, but our new array has the values multiplied by 2. And just like with for each, we still have access to the current index as well as the array, so we could do something like I, maybe do num times I. So now we have 0, 8, and negative 40, so this was 5 times 0, this was 8 times 1, and this was negative 20 times 2. Again, because we are multiplying our num times the current index. Now another method we have that's very similar to map is going to be the filter function. And what filter does is it is going to create a new array with only values where we return true. So for example, if we were to say num is greater than 4 here, we would get a new array with just 5 and 8 because negative 20 does not fulfill this condition of num being greater than 4. So we return false in that case. If we did something like just return true, you'd see we get the same array. If we return false here, we would get an empty array. And if we wanted to, we could even sort of combine these together. So maybe we want to filter by, let's do num is greater than 0. So we'll just get the positive values. And then let's chain a call to map. So we know that this returns an array, so that array still has access to the map function. So let's chain a call to map. Let's say in this one, we want to take our current number, and maybe what we want to do is return our number times 2. And now you'll see what we have is 10 and 16. So we have the values from this array that were positive, so 5 and 8, and we multiplied them by 2, and we get 10 and 16. And now this would also be a good time to remember that we have shorthand syntax for callbacks, which can actually make this look a lot cleaner. So what I'm going to do is take this and remove the parentheses and I because we're not using it. And then I'm also going to put this on one line without the curly braces. So we can do this just like this. And then we can do the same thing with map. So we don't need these parentheses and we don't need the curly braces. So we can get rid of those. And we also won't need the return statement as well. So let's get rid of that. And we could put this all on one line like this if we want to without that semicolon. Or we could do something like nums.filter on a new line and then .map like this. This is a common way to sort of organize this code to make it very clear of, okay, first we're doing this filter and then we're doing this map to change the values in some way. Now, finally, the last of these functions that I want to show is a little bit different. So I'm going to remove all of this and we're going to do nums.reduce. And reduce is going to take in another callback function. And this callback function is going to have two primary parameters. The first we oftentimes label as ACC for the accumulator, and the second is going to be the current value. So sometimes we just say this is going to be cur, and then we can open up this callback function. And what the purpose of reduce is to take the array and reduce it into a single value. And essentially what this is our cur is going to be our current element in the array, and the accumulator is the value we returned from the previous call. So for example, if we do return the accumulator plus the current value, accumulator is going to start at just the first value, which is 5, and then we start iteration from the second value, so we have 8. So we have 5 plus 8, and then that's going to be 13. And then for the next call, we now have an accumulator of 13 and a current value of negative 20. So we again add them together and we get negative 7. And then when we get to the end, we just return the accumulator. So this essentially is summing up all of the values. So we could say let sum equal this call, and we can come down here and do console.log our sum, and you can see we get negative 7. And just to show this a little bit better, let's come in here and say console.log, and let's log out our accumulator and the current value. We can run this, and you can see the first iteration, the accumulator starts at 5 with the current value of 8, and then we have the accumulator of 13, so 5 plus 8, and the current value of negative 20. And if we added, say, one more value here to make this even more clear, now we have negative 7 as the accumulator and the current value of 10. And we add those together again, and now we have 3 as the final console log, so the sum of these values. And now in some cases, you don't want to start with the first value, you want some default initial value. So for example, we can come down here after our callback function and add another parameter, which is going to be the starting value. So for example, I can say maybe we start at 100. Now, if I run this, you'll see we end up with 103. So this is going to start with 100, and then the current value is going to start at 5. So we do 100 plus 5 is 105, 105 plus 8 is 113, 113 plus negative 20 is 93, 93 plus 10 is 103. So now we end up with a sum of 103, starting from an initial value of 100. So most of the time in JavaScript, when we have an array and we want to do some iteration through that array, we will tend to prefer these methods on the array rather than using a traditional for loop. So most of the time, if we're just iterating through the array, we'll want to use for each. If we are creating some new array with new values based on the previous array, we'll use map. And if we are filtering out the array, so removing some elements, we'll use filter. And then on occasion, we might use this reduce function, which allows us to take the entire array and reduce it into a single value. That said, there are a few other of these iteration methods, but these are the most common ones, so the ones I wanted to show in this video. Next, I want to briefly revisit objects to discuss how we can actually iterate through them as if they were arrays. So here we have an object with 3 key value pairs. So we have A is 1, 2, 3, B is 4, 5, 6, and C is 7, 8, 9. However, sometimes we still want to just iterate through all of the keys and values, and we have a few different ways to do that. So first I'm going to come down here, and what I want to do is just say console.log. We're going to log out a call to a function that is object, so this is capital O object, dot keys, and then we can pass in an object like our obj, and when I run this, you can see this actually returns this array with A, B, and C. So these are our keys. So what does that mean? It means if we want to actually iterate through the object, what we can do is we can simply say object.keys for each, because this is an array, and we could get each key, and then we could come in here and say console.log our key, and then we can run this and you can see we get ABC. Or if we wanted to, we could do obj at our key, and we would get 1, 2, 3, 4, 5, 6, and 7, 8, 9. And now if maybe we don't actually need the keys, we just need the values, we can actually use another function that is very similar. That's going to be object.values, and it's going to give us each value. So we can say we have each value, and let's come here and do value like this. And you can see we get 1, 2, 3, 4, 5, 6, and 7, 8, 9. So now we are just logging out the values, and like this, we don't actually have access to the keys. And if we do need both, we have object.keys like we saw, and then you can just get the value out of the object. But another option is to use object.entries, and this is going to give us entries. So let's say each one is an entry, and for now, let's just console.log our entry, and you'll see that these are actually arrays. So the first value is the key, and the second value is that value. So we can say entry at 0 and entry at 1, and that's going to give us the key and the value. Now, one thing you might notice is that we are getting these values in order. However, I do want to reiterate that JavaScript objects, while they do technically actually have a defined order, it's not always what you would expect. So the general rule that's usually accepted everywhere is to never rely on the order of objects. So even if this feels like it's in some order, if you actually need an ordered data structure, you should likely be using an array, not an object. Now, in addition to object.keys, object.values, and object.entries, we do have one other way that we can actually iterate through an object. That is going to be the for in loop. So we're going to say for, and this is going to work similar to the for of loop that we used with arrays, but this is a for in loop. So we can say let our current property in our object, and property in this case is going to be the current property we're on. So we can say console.log our prop, and you'll see we get ABC. So this works almost the exact same way as object.keys. So for example, we could do obj at our prop, and you would get the values like that. Or if we wanted both, we could log out our property and obj at the prop. There are some very subtle differences in how for in works compared to object.keys, specifically with how it works with inheritance, with the prototype chain as we call it, but we're not going to go into all of that right now, and just know that in the vast majority of circumstances, for in as well as object.keys are going to end up giving you the same result. And personally, when it doesn't matter, I do tend to use object.keys, object.values, and object.entries more often than I use the for in loop, just because I tend to prefer that functional style, but either is perfectly okay. Now I want to look at how we can actually sort an array, so how we can change the order of the array to be in some order that we want. So for example, here we have an array of strings with DEF, ABC, and ZZZ. And maybe we want to sort this array to be alphabetical. And there's actually a very simple way to do this. So we can take our strings array and simply call .sort on it. So this is a method that all arrays have, and it is going to sort the array. Now this is an in-place sort. So what that means is it's going to sort it in the original array. It's not going to create a new array. So now if we come down here below and we do console.log, our strings, you'll see that strings is now sorted. So we have ABC, DEF, and ZZZ. So this is simply sorting alphabetically. However, there is a bit of a caveat to this, and that's that in JavaScript, we have lots of different types, right? And somehow this sort function needs to know how to handle all of the different types. And what it happens to do is it essentially just converts everything to strings. That's sort of how it sorts. So if we were to come in here and have numbers, say we have the number 1, the number 5, and the number 3, this will still work. However, what would happen if, say, we have 30 here instead of 3? Well, now we get 135. And why is that? It's because sort is treating these values like strings. So it's essentially doing the same thing as sorting this, this, and this. And when we compare strings, like when we alphabetize things, we take it one character at a time. So it's saying, okay, 3 is less than 5, so therefore 30 is less than 5. And of course, that's not actually what we want. So a common cause of bugs is actually using this built-in sort function on numbers. So let's actually make this say nums so that it is a bit more clear. And just in general, I would avoid using this default sort with nums. However, within sort, we can actually pass in a callback function that allows us to control this. So this callback function is going to take in two values, a and b. And this is a comparison function. So essentially what we're doing is we're saying, okay, given two values, such as maybe 1 and 5, or 5 and 30, or 1 and 30, given these two values, we just want to tell JavaScript which one is actually the greater value. And I'm going to paste something in here. This is actually from the MDN documentation. This is essentially the rules of how this comparison function needs to work. So if we return a number greater than 0, so we're always going to return a number. If it's greater than 0, we sort A after B. So we have A and B as our parameters. So we end up with BA essentially. If we have a number less than 0, we sort A before B, so we have AB like this. And if we have equals 0, we're going to keep the original order. So we're saying they have the same value, just leave them as they are. So for example, if we came in here and said return 0, well, now we're saying that this is already sorted. So we end up getting 1530 exactly how it was. But even if this was not sorted properly, so say we had 5130, we still have 5130 because return 0 says keep the original order. But if we want to say we want these sorted in ascending order, well, the common way to do that is to say return A minus B. So we are going to now end up with 1, 5, and 30. And the way this works is imagine that we had A is 5 and B is 1. Well, 5 should be after 1. So we do 5 minus 1, that gives us 4. And that is greater than 0. So therefore, we sort A after B because we ended up with that positive number from 5 minus 1. Likewise, if say A was 1 and B was 5, we would end up with 1 minus 5. And 1 minus 5 is going to give us a negative number, so we sort A before B in that case. And similarly, if we want to go in the opposite direction, then what we can do is say sort by returning B minus A. And this is going to give us 35 and then 1. So essentially the key point here is that we have this sort function and it's going to work great for strings. However, if we're using numbers or something else, we'll likely want to make a custom comparison function. And in that comparison function, these are going to be the rules of how we compare the two values and what it actually means. So we're going to be returning numbers. And if we want to sort numbers in ascending order, we'll want to do A minus B. And if we want to sort the numbers in descending order, we will do the opposite, so B minus A. Next up, I want to look at a few different ways that we can actually declare variables. So we've seen let so far, but we can actually do it in two other main ways. That is using the var keyword and the const keyword. So var works very similar to let, and we'll look at some of the differences. But first, I do want to just preface this by saying that we usually don't actually use var anymore. It's not officially deprecated. It's still part of the language, and I think it's important to understand. But the general recommendation and consensus across the industry is that there's really no reason to be using var in modern code bases, but I do still think it's important to understand. So first, let's just change this let to a var, and we can run this, and you can see it works the same way. And just like let, I can change our variable. So maybe we can say num plus equals 10, run this, and now we have 20. So var works the same way as let in that regard. However, the major difference is that var is going to be function scoped or globally scoped, whereas let is going to be block scoped. So what does this mean? Well, if we have an if statement, so let's say if, and we'll just do if true here, and we put this variable inside, well, this is still going to work. We still get 10. However, if we used let here, we would actually end up getting an error. So we see num is not defined, because with let, the variable is scoped to this block. Whereas with var, because we are not in a function, it's just scoped globally. Now, if this was a function, so if instead of this if statement, we just had some function, I'll just call this foo. And now with let, we still get an error message, but same thing with var. So with var, it is scoped to this function. So num still is not going to exist outside of the function. There's also one small difference that has to do with hoisting, and this usually shouldn't be something that actually comes up, but I still think it's somewhat interesting and a point to still know. So let's say that we did var num equals 10 here, and we run this, you'll see we get 10. But what would happen if we move this after the console log? You might think, okay, this should throw an error, but we actually get undefined. Whereas if we did this with let, we actually do get an error. So we see cannot access num before initialization. So the difference here has to do with hoisting. So when we use var, this is actually the equivalent of just taking this code and putting it all the way at the beginning to declare our variable and then initializing it down here to its value. So this is essentially what JavaScript automatically does for us when we use var. However, I think a lot of people saw this as generally just sort of confusing and sort of an unexpected behavior. So when let was added to the language, they changed this to where this is no longer the case, and it will not actually allow you to access that variable before it gets initialized down here. All right, so those are the main differences between let and var, and really the big takeaway should just be that there's no reason in a modern codebase to be using var anymore. But now I want to look at one more keyword, and that is const. So let's say const, and we'll put this as num and set it equal to 10. And again, this is going to work. And const actually works the exact same way as let. However, this creates a constant. So const stands for constant. And what does that mean? Well, simply it means that we can never reassign this variable to something else. So we could never do num equals something else again. So if I say num equals 20, you'll see I get an error assignment to a constant variable. This would be true even if we tried to do something like num++, because this, again, is just shorthand for assigning num to a new value. So at the surface level, this works the exact same way as let, however, we cannot reassign the variable. And this is still going to be block scoped. So for example, if we said if true here, and we move our constant inside of the if statement, you'll see we get the same reference error num is not defined. So this works the same way as let in that you cannot access a variable outside of the block that it was created in. But now constants might not work exactly how you always expect them to. So what would happen if, say, this was an array? So if, say, we have 1, 2, 3, and we run this, and let's make this nums instead of num, you'll see we still get this array. And we cannot change this array by reassigning it. So I cannot say nums is now equal to this array with 0 because I'm trying to assign to a constant variable, which is not allowed. However, that does not mean that this array is immutable. So I could do something like nums.push 4, and this now has a 4 in it. So why is this allowed? Well, const says you cannot reassign, but we didn't reassign it. This still is the same variable. It's still pointing to the same array. That array just has different values contained in it. So it's pointing to essentially the same object, even if the values within that object changed. So const does not mean that the object or array is going to be immutable. It simply means we will never reassign. And the exact same thing would be true with an object as well. So let's say that this is going to be an empty object, and I'll name this obj. Instead of nums.push, let's say obj at, and let's just say num is going to be equal to 10, and let's print out our obj, and you'll see we do have our num is 10. So I cannot reassign this. I couldn't do something like obj equals some other empty object. That would give us this type error assignment to constant variable, but we can change the values within that object because it is the same object. And now we said that we shouldn't use var in modern codebases, but when should we use let and when should we use const? And well, there's actually not a super straightforward answer to this because people don't fully agree. So some people are of the opinion that we should use const 100% of the time and only use let if we need reassignment. And by doing that, it's essentially making the let keyword mean something more. It's making it mean, hey, this thing is going to be reassigned. Whereas other people say just use let all of the time, it's simpler that way, and only use constants for sort of true constants. So when we have like some config at the top of the file. So for example, maybe we're working on some kind of store and we have something like some tax rate and we want to say const tax rate is going to be equal to 0.1 to represent a 10% tax. So oftentimes you'll see these sort of top level constants in all uppercase with this underscore naming convention. And then some people say with everything else, just use let. Or some people say, well, do this for the top level constants, and then for everything else, still use const unless we have to use let. And then sometimes you'll see other conventions that'll be something like using constants only for creating these top level arrow functions like this, and then everything else to just use let. So really the point I'm trying to make is that there's not an agreed upon standard across the industry. There's been attempts to make standards, but they're not completely followed from one place to another. So within different code bases, you might see different practices. And the most important thing is just to be consistent within the code base you're working in. In my own personal work, I tend to follow this practice of using const with capital letters for these sort of top level constant values. And then for all of the variables throughout the code, just using const with lowercase naming. So something like foo, or with camel case, so something like foo bar for whatever variables I have throughout the code. But again, at the end of the day, it's mostly up to your own preference, and there's pros and cons to multiple different approaches. Next, I want to look at the difference between two things, known as passed by reference and passed by value. So here we have a function called foo. It takes in an array, and it pushes the number 7 to that array. And then we have this nums array with 4, 5, and 6. We call foo with nums, and we log out nums. So what do we think is going to happen? Well, nums gets passed into foo, so it becomes our array, and we push 7 onto it. But does that 7 exist outside of this foo? Well, if we run this, the answer is going to be yes. We have 4, 5, 6, 7. So what does this tell us? Well, it tells us that inside of foo, the array that we are editing is the same array that we have out here. We are pushing onto the same array. We're not getting a duplicate of that array. We are actually changing the original array. This is known as pass by reference because what we actually pass into foo here as this argument is a reference to this array. So we are always using the same array. We're not using a duplicate of it. So whenever we change the array inside of foo, it is actually changing this nums array here. And the same would be true with any type of object. So let's instead say we have some obj. Let's do something like obj at a is simply going to be equal to 10. And then let's pass in some object. So let's say we have my obj is going to be just an empty object. And let's call foo with my obj. And then let's log out my obj. So we can say const.log my obj. And you can see we have a is 10 here because this is editing the actual object. Now, it's worth noting that if we did something like obj equals and then some other object, so maybe we have an object with b is going to be 1, 2, 3, well, this changes this value, but it does not change the original object. So if I log this out again, you can see my obj is still the one with the 10. So this is changing what the obj variable name points to, but this here, before we did this, was editing the original obj. So originally, obj is my obj, which is this empty object here. So we add this property of a with the value of 10 to it, and then we change the obj parameter name, so this variable, to point to this new object here, but that is not overriding this object. This object still exists in our memory. We just no longer have this obj name for it, but we still have the my obj name for it. So this is a completely different variable pointing to a different object now, and we've already edited that object. So essentially what this means is that whenever an argument to a function is some kind of object, if we edit that object within the function, it is going to edit the object that we passed in. It's the same object. Of course, if we change what the actual parameter is, if we just assign it to something else, then we sort of within that function have lost access to that original object, even though it still exists. So we'll be editing something else. But if we're not reassigning that variable, which we really shouldn't be doing in most cases, so something like this is sort of considered a bit of an anti-pattern. If we're doing something like this, though, we are going to be editing that original object. Now, if we had some just primitive value passed in here, so say we have some num, and all we do in here is maybe say num plus plus, and then let's come down here and say we have my num is going to be equal to 10, and we're going to call foo with my num, and we can log out my num, and you see it is still 10. So this is a primitive value, right? My num is simply a number. It is the number 10. And primitive values are not passed by reference, they're passed by value. So whenever we do num++, it is only doing num++ within foo. It is not going to change my num. And the same would be true with any primitive. So if we passed a Boolean or a string or anything like this into our foo function, that function is not going to be able to change the outside variable simply by editing the parameter value. Of course, if the outside variable is in scope in some way, it could edit it that way. But if we just pass in a parameter as a primitive value, it is going to be passed by value, meaning that we are not going to be editing that original value. We essentially have a duplicate of it inside of this function. And this is something that can tend to sort of trick up new beginner programmers. But as you get more experience with it and you just sort of use it more, it will become more natural. And I think you'll just start to understand when something's going to be passed by reference versus passed by value, and when you'll sort of be creating duplicates of something versus editing the original values. Now I want to talk about the idea of equality and how it relates to objects. So here we have two objects, obj1 with foo set to bar and obj2 also with foo set to bar. So these two objects are essentially the exact same. However, if we check to see if they are equal using the equality operator, so for example, if we do obj1 triple equals obj2, we're going to get false. And this would also be true with loose equality as well. So this is still false. So regardless, these two objects are not equal to each other. In fact, even if we have two empty objects, so let's remove the foo is bar here, we still get false. And again, same thing with loose equality. So the key point here is simply that we cannot use the equality operators to compare two objects. The only way we would get true here is if they were the same object. So for example, if we do obj1 triple equals obj1, of course that would be true. Or if we did something like obj2 equals obj1, well, now if we check obj1 versus obj2, this would be true because they point to the same object. They are both this exact object. However, if they point to different objects, even if they have the same contents, this is always going to be false. And the same is true for arrays. So arrays are just sort of a special case of objects. So if we have two different arrays, we'll call this array 1 and array 2. So if we have these two arrays and we check equality of the two arrays, we still get false. Same thing again with loose equality. So with any type of object, if we compare them using the equality operators, if they are different objects, even with these same exact contents, we are always going to get false. So what this means is that if at any point you have two objects and you do need to compare them for equality, there are a lot of different options, but just know that you cannot use the equality operators. So for example, with arrays, you can check that they have the same length, and then you can iterate through the arrays to see, okay, do they have all of the same values? And then for objects, you can do something similar. You can check that they have the same key value pairs. And then you might need to do something like also checking if there's any nested objects and comparing those. But just generally speaking, you'll have to write your own function to somehow do that comparison instead of using the equality operators. Next up, I want to look at something known as type coercion as well as type conversion. So this is some code that we've actually seen before. So we're console logging 5 is loosely equal to the string of 5, and we know we get true here. And what's happening here is actually something known as type coercion. So type coercion is simply when JavaScript is going to automatically for us change the type of some value. So in this case, we're comparing a number 5 to the string of 5. So it's going to need to do a type coercion to make these the same type so that they can actually be compared. On the other hand, type conversion, which we also sometimes call type casting, is going to be the process where we as the programmer explicitly say, hey, I want to convert this string into a number or this number into a string or whatever type into some other type. So type coercion is when it happens just automatically, and type conversion or type casting is when we actually explicitly choose to convert types. And this actually happens in a lot of scenarios in JavaScript beyond just the equality operator. So for example, what if we did 5 plus 5 like this? Well, what happens? Well, we have a number 5 and then plus and then a string of 5. But plus could be either addition because we have a number, or it could be concatenation because we have a string. And in this case, it actually is concatenation. So whenever we have the plus with at least one string, it's going to concatenate. And even if we had something like true here, it's going to convert this into a string. So you can see we actually get this string of true 5. Now, what's interesting is if we go back to 5 plus 5 and change it to minus, well, minus only has one meaning. It only is subtraction. So it says I'm going to convert this string over here into a number so that it can actually do that subtraction. And you'll see if I run this, we actually get 0. I'll make this a 4 so they're different numbers, and you can see we actually get 1. And this would even be the case if they were both strings, because again, subtraction is an operator that only accepts numbers. So it's just going to try its best to convert both of the operands into numbers. And even if they're not numbers at all. So if we did something like true minus 4, and 4 is a string, we're actually going to get -3. So true converted to a number actually gives us 1. So we end up with 1 minus 4, which is -3. And if we did false, well, false converted to a number is actually going to be 0. So we end up with -4. And then if we did something like, say, true minus false, well, this is 1 minus 0. So we end up with 1. Now, of course, most of the time we don't want to be doing this. We don't want to be trying to do math with values that aren't numbers. However, it is still important to understand how these things actually work within the language. And this type coercion actually happens in other cases as well that have nothing to do with math. So for example, what if I was to come over here and just say console.log not true? Well, this is false, and we know not false is true. However, what would happen if I did not 5? Well, what is this operator going to do? Well, it's actually going to give us false. So what it does is it says, okay, I guess take this number and just make it into a Boolean somehow, and then invert that because we're saying not. So any number that's not 0 is going to be true. So we end up with true and then not true, which is false. And you'll see if I put not 0, we get true because 0 is the only number that is going to evaluate to false. And we'll actually have a similar result if we use strings. So if we do not an empty string, we get true. But if we do not and some string that actually has text in it, we get false. So it's going to convert this string into a Boolean, and any string that has anything in it converted to a Boolean is true. So not true is false, but an empty string converted to a Boolean is actually going to be false. So then we have not false, which is of course true. Okay, so those are a few ways that we can do type coercion, but I also want to look at some type conversion. So if we want to, say, convert some value to a Boolean, one way we can do that is simply by calling this Boolean function. So we can pass in any value here. So for example, let's pass in 10, and you'll see we get true. If I pass in 0, we get false. So this is Boolean with a capital B. This is actually a constructor function. So what that means is you can actually use it in a way to create an object, but we're not going to go into that right now. Most of the time when we use this function, all we want to do with it is pass in some value and it's going to convert it to a Boolean. Of course, if we passed in a Boolean, we just get the same Boolean back. One sort of interesting test I like to do with this is to ask what exactly would happen if you did this. So if we pass in the string of false into the Boolean function, what do you think would happen? Well, we saw earlier that an empty string is false and any other string is true. So you might think, okay, this is false because it literally says false here, but that's actually not the case. It is in the category of any other string. So if I run this, you'll see we get true because any string that is not the empty string, so empty string is false, but any other string is true, including the string of false. Some other values that might be interesting to you are something like null is going to be false. Same thing with undefined is also going to be false. We could also pass in arrays and objects here. So if we passed in, say, an empty array, we get true. Same thing with an empty object. So any object essentially is going to be true. Now, as an alternative to this Boolean function, we saw that we could do not and then some value and it converts it to a Boolean and inverts it. So not 10 is false. But what would happen if we did not 10? Well, not 10 is false and not false is true. So what this actually does, if we have these two exclamation marks, is it first of all converts the value to a Boolean and then it inverts it and then it inverts it again. So this is actually another way to just convert any value to a Boolean. Sometimes we see this called the double exclam or the double bang, and essentially it works the same way as that Boolean function. So we'd get all of the same results. So if we did, say, an empty array, we get true. If we did an empty string, we get false. So this is going to give you all of the same results as that Boolean function. Personally, I tend to use the Boolean function over this just because I think it's a bit more readable, but some people do like this, so I think it's important to show as well. Now, the last thing I want to show in this sort of section on explicit typecasting is going to be numbers. So there's actually a lot of different ways to convert values to numbers. So I want to look at them one at a time and see the different options that we have. So first of all, sort of the most narrow, and that's a function we have called parse int. So parse int like this, and it takes in some value. So for example, 10 is going to give us 10. And if we had, say, the string of 10, it would give us the number of 10. And if we had some other characters here, it would actually just give us that number of 10. So it's going to cut off any characters after that number. Even if there's more numbers after here, like this 8, it's not going to include them. It just goes until it doesn't see a number anymore. Additionally, this is parsing an integer. So if we had something like 10.5 here, it would still give us 10. In fact, even if this was a number, it would give us just 10. So it removes any decimal values. And really where I think parseInt is most useful is if we have something like, say, 10 pixels. So this might be a value we get from our HTML or CSS. So oftentimes when we're working with the browser, we might get things that have units and we want to remove the units in JavaScript. So an easy way to do that is to use the parseInt function and pass in that string. Now, as an alternative to parseInt, if we don't need an integer, we need a decimal value, there's also parsefloat. So this here would give us still 10, but if we had, say, 10.5, it would give us 10.5. So it's going to do the same thing as parseInt, except it's not going to remove those decimal values. Now, if we did have extra numbers after the characters, we get the same behavior where those are not counted. So it goes until it finds something that's not part of a floating point number, and then it just stops including that. However, parseInt and parsefloat are not the only options we have. We also have, similar to Booleans, a number function. So this is capital N for number. And this is, again, a constructor function that can allow us to create objects, but most of the time we just call it to create these number primitives. And if I passed in something like 15, we'd get 15. If I pass in 15.5, we get 15.5. And if I make this a string, we get the same behavior we saw with parsefloat. So we're going to get the entire decimal number. Now, an interesting point where number differs from parsefloat is if we have something that's not a number in this string. So for example, if I had 15.5 px, this is going to give us NaN. So NaN, which sometimes people pronounce it nan, actually stands for not a number. We'll be going more in depth on what exactly this NaN value actually means. However, for now, just know that what this means is that it saw this and said, that's actually not a number. I don't know what to do with this. So it just returns this generic NaN value to us. So that's sort of why if you're doing something like removing the px from pixel values, you'll want to most likely end up using the parseInt or maybe even parsefloat functions. However, for more generic things, oftentimes we want to use number. And this will work for other types as well. So for example, true is going to give us 1, false is going to give us 0. Something like the empty string is also going to give us 0. If we did something like an empty array, we get 0. However, if we do an empty object, we actually get that NaN value again. And interestingly, if we do null, we actually get 0. However, if we do undefined, we are going to get NaN again. And I know this is sort of a lot, but the point here is not to memorize all of these different behaviors. More so, I'd say the point here is to know that these different behaviors exist, and they're a bit confusing. There's a lot of them, and they don't always do exactly what you might expect. So the bigger takeaway should be that you should, as much as possible, avoid type coercion and type conversion because it can likely lead to behaviors you don't expect. because you probably won't be able to memorize what all of these different behaviors actually are. And now finally with numbers, I did want to show that there is actually one other way that we can convert to a number, or at least one other primary way. There's actually a lot of ways we can do this, but that is going to be using something known as the unary plus. So this is just going to be plus, similar to addition or concatenation, and we can do something like plus and the string of 5. This is going to give us the number of 5. Same thing if we did something like plus true, this would give us 1, or plus false, this would give us 0. So if you put the plus sign before some value, it's going to convert it to a number. So plus array is going to be 0, plus an object is going to be nan. So we're going to get essentially the exact same behavior as that number function. However, it's just a little bit more concise using this unary plus operator. So some people prefer this, other people prefer using the number function. Personally, I prefer the number function. I think it's a little bit easier to read, especially if we have a lot of stuff going on. This plus is just so overloaded. It could look like addition, it can look like concatenation. So I think it's just a little bit confusing to also be using it for type conversion. However, it is important just to know that that is another function of the plus sign. Now I want to look a bit more deeply at this idea of nan or not a number, as well as we'll also look at the infinity values in JavaScript. So here we're logging out number of the string ABC. So we're trying to convert the string ABC into a number, and we get this value of nan. So again, nan represents not a number. And essentially what this means is that we tried to do something that should result in a number, but there was no number to get, so it returns to us this nan value. And there's actually a ton of ways in JavaScript to get nan. So for example, if you do a lot of math functions that should return a number with something that is not a valid number to that function, it oftentimes gives you nan. So for example, if we do math.sqrt, which is the square root function, and pass in a negative number, we are going to get nan because you cannot take a square root of a negative number, so it's just what it returns to us. And now nan as a value is actually a little bit quirky, and the biggest part of this is that nan is never going to be equal to any other value, including nan. So if we were to do constant log nan strictly equals nan, we get false. Same thing if we do nan loosely equals nan. And what's actually even a bit crazier here is if I was to do something like const val equals nan, and if we were to simply check, is val loosely equal to itself, we still get false. So no matter what, if we use nan in an equality operator, even if we're checking nan versus itself, we will just always end up getting false. But then you might be wondering, okay, how do we even check if we have the value of nan? There's actually two different functions for this. So that's going to be the isNaN function. So we're going to say isNaN, and we can pass in our val, and you can see we get true. But if val was, say, 10, we would get false. However, I would actually never recommend using this function, and that's because it doesn't do exactly what you might think it does. So what isNaN does is it takes this value and converts it to a number. So if, say, we had the string of 10, it's going to convert it to the number of 10 and say, did I get nan in that operation? And the answer is no, so we get false. However, if we had something like, say, the string of ABC, we are going to get true, even though this is not the value nan, this is a string. But why did we get true? Well, if you were to do number of the string ABC, what do you get? Well, this we know is nan. So that is actually what it does. It converts to a number and then says, did I get nan? If I did, return true, otherwise return false. And this just isn't usually what we want. What we want is to say, is this nan or is it not? And there's actually a different function for this, and that's going to be on the number object. It's going to be number.isNaN. And this is going to work how you sort of expect. So we're going to get false here because the string ABC is not nan. Same thing with the string of 10, same thing with the number of 10, and any other value except for nan, where we will get true for that value. So nan gives us true, everything else gives us false. And that's probably more of what you expect. So if you want to check if a value is nan, I would pretty much always use number.isNaN rather than the top level isNaN function. Now, in addition to nan, there are a few other sort of special math values, and the most important, I think, are going to be the infinity values. So I wanted to show those as well. So let's get rid of this. Let's do something like constant log 10 divided by 0. And this is something that's been debated at times as to what this should return, because you cannot divide by 0 in mathematics. So you might think this returns nan, but what JavaScript chose to do is actually return this value of infinity. And infinity works pretty similar to infinity in mathematics, but it is slightly different. And really the way I like to think about it is simply it represents a value that is higher than any other number. That is really the best way to think about infinity. So if we were to do something like infinity is greater than, and then any number, we're always going to get true. So even if we just have a ton of 9s, of course, we still get true because infinity is considered the highest possible value. And then we also have a negative infinity as well. So we can say negative infinity, this would be false. But if we were less than this number as a negative, we would get true. So negative infinity is the lowest possible value. And we get negative infinity naturally when we do something like -5 divided by 0. This would give us negative infinity. And we can also use infinity values in other operations. So we could do something like infinity times 10, and this would still just give us infinity. But infinity times -10 would give us negative infinity. And interestingly, sometimes if we do something that combines infinity and negative infinity, where it just doesn't make a lot of sense. So for example, infinity plus negative infinity, we're going to get NaN. So you might think, okay, these are opposites, so we should get 0 or something like that. But no, we get NaN if it doesn't make a ton of sense as to what this operation should actually do. But really, most of the time, I would avoid using these infinity values if you can. Really, the only time I do end up using them is if I just need some value that's always greater than any other value. Then in that case, using infinity should make sense. But using infinity for some like math operation is not something I would usually recommend. And with NaN, I can't think of any scenario where I've ever needed to explicitly assign some value to NaN. However, NaN is something that you'll oftentimes need to check for when you're doing sort of math operations to make sure that the value you're getting is an actual number and not this NaN, not a number value. Next, I want to look at how we can actually determine what type some value is, and that is going to be by using the Typeof operator. So here we have this val constant set to hello world, and we want to check, okay, is this a string? Is it something else? How do we know what it is? Maybe we have some if check where it's taking in some value and we don't know what it's going to be, so we want to do something different based on what type we have. And the way we can do this is by using the Typeof operator. So it's going to be typeof and then whatever we want to check the type of. So in this case, our val, and you can see we get string. So this actually returns to us a string of what type this is. So this itself is actually a string. And if we made this something else, we would get something else. So for example, if this was 10, we would get number. If this was true, we would get a Boolean. If this was, say, undefined, we would get undefined. If maybe this was an object, we would get object. So for the most part, this probably does what you expect. It just returns to us a string of what type we have. However, the Typeof operator does actually have some quirks. The first of which is going to be null. So you might think, okay, the type of null is null, so that should be what we get. But in fact, we get object. And I'm not going to go too in depth on why exactly this happens because it's actually a bug. It is a mistake that was made in the early days of JavaScript, and there was actually an attempt to fix that bug, but they decided that it would sort of break backwards compatibility with all of this code that's existed for so long that assumes type of null is going to be object, when it should be null, right? Null is its own type. But because of that backwards compatibility, essentially they decided it's not worth fixing the bug. So forever now, type of null is going to be object instead of null. And the two other ones that can be a bit strange are first of all going to be arrays, which you might think, okay, this should be the type of array or something like that. But in fact, this is also an object. Although this might make sense to you as well because we have said arrays are themselves objects. So in a way, it does make sense that the type of an array is going to be object. However, there's one more exception, and that's that every object is going to return object except for one specific type of object, and that might be one they don't even know is an object, but technically they are, and that is functions. So let's create a function. So let's say function myfunc, and let's just say all this does is console.log hello, and technically functions such as our myfunc are actually objects. So functions in JavaScript just are objects. However, this is sort of special cased. So if we log this out, you'll see we actually get function, and function is not a type in JavaScript, but that is what you get when you do type of and then some function. And this would be true of any function. So even if we did something like const myfunc is going to be equal to an arrow function, this would still give us function. So this is true of arrow functions as well as our traditional functions. And now one more sort of quirky value that you might not expect is going to be NaN. So what if I did type of NaN. You might think, oh, this should be NaN, but NaN is actually not a type. So this is going to be number. So NaN is not a number, but its type is actually number, which in a way makes sense because NaN, while it represents not a number, represents sort of not a number in these numerical contexts. So when we do something math related that doesn't give us a real number, we return NaN. So it actually does sort of make sense that NaN is of type number, but sometimes this can be a bit confusing for people. Now, as a sort of test, what do you think this will return? Type of NaN. Of course, this isn't something you would ever actually do, but just to see how deeply you understand this concept. Okay, so we have type of, and this is giving us type of whatever this results in. So whatever's the operand on the right. And type of NaN we know is number. But remember, type of itself returns a string. So this is the string of the text number in all lowercase. This is why if we wanted to check, oh, is this a number? What we actually do is we usually do something like strictly equals the string and then in all lowercase, whatever type we're checking against. So this would be true. So if we go back to type of NaN, we know this is the string of the text number. So then type of this string is actually string. So we're going to get string here. So we get the string because type of is going to be the type of all of this, and the type of this is itself a string. But again, this is just a fun problem. It's not something you'll actually be doing. And the important points here are simply that type of is a way to check the type of some value, but you should know that it does sort of have some quirks. The most important being that null is going to be type of object, that NaN is going to be type of number, and functions are going to be type of function, even though function is not actually a type in JavaScript. Next, I want to look at the idea of Truthy and Falsy, which is essentially just how JavaScript is going to handle whenever we use some value in a Boolean context, so somewhere that expects a Boolean, such as an if condition, when that value might not actually be a Boolean. So for example, here we have my val is 10, and we say if my val, console log my val is truthy, otherwise log out my val is falsy. But what does this even do if my val? Well, my val is not a Boolean. So it's going to check, is this a truthy or falsy value? And in the case of the number 10, we get my val is truthy because this is a truthy value. So we get into this if condition. And that's going to be true of any number except for the number 0. So if I change my val to 0 and run the code, you'll see we get into this else statement because my val is a falsy value. And any other number, so even something like the number 1, we'd get into truthy. Same thing with -1, it is still truthy. We do also, of course, have the value of NaN, and this is going to be sort of a number, but it is going to be falsy as well. So NaN is falsy as well as 0, but any other number is going to be truthy. And something similar is going to be true with strings. So if I have the string of ABC, we get my val is truthy. Same thing with, say, the string of 0, still truthy. But an empty string is going to be falsy. So empty string is falsy. Any other string is going to be truthy. Now with null and undefined, they will both be falsy. So if we do null, we have my val is falsy. Same thing with undefined, we will get my val is falsy. And there's a few very small exceptions, but pretty much any other value is going to be truthy. So for example, any object, including an empty object, is truthy, or even an array is also truthy. Same thing actually with a function. So if we have some function, this is also going to be truthy. And a lot of times you will see code that looks just like this. So if some value, and then if that's truthy, do something with it. So essentially saying, if this value exists, do something with it. And a lot of people do like this. Personally, I don't tend to actually do this very often because I think it can just be a little bit confusing. I prefer to be more explicit because what if, say, my val is a number? So say we have the number 10 and we want to do something when we have a number. So if we have this number, we do something inside of this if statement. But then what happens if something makes the number become 0? Well, now we no longer get into this if check and we end up in the else. But my val still exists. We still have a value here. It just happens to be 0. And maybe there's some circumstance where you want to get into the if statement only if you have a number that is not 0. But typically, I don't think that's very likely, and I think you're more likely to just introduce some bug where your code doesn't work for the number 0, because 0 ultimately is still a number. So personally, I do like to just be more explicit, but it is, at the end of the day, just a matter of personal opinion. Now, I do want to show that this idea of Truthy and Falsy exists outside of just if statements and conditionals and things like while loops, there's also other times when Truthy and Falsy is going to come into play. So for example, let's say we have an array with the values 2, 4, 6, and 8. And then what we want to do is filter this array. So let's say const new array is going to be equal to our array dot filter. And we've seen this function before. What it's going to do is take in our current value. And if we return true, so if we say just return true here for every single value, then we're going to end up with a duplicate of the same array. So we can do console.log our new array, and you'll see we end up with 2, 4, 6, 8. And whenever we return false, we end up with an empty array. But it's actually not explicitly checking for true or false. It's checking for truthy and falsy. So for example, if we just did return cur, we would end up with the array again because all of these values are truthy. Now, of course, if say we had a 0 in this array, 0 would be removed because 0 is falsy. So returning cur is going to give us a truthy value for everything in this array except for this 0. And again, this isn't something I personally like to do just because I do find that this is a bit of a confusing thing and something that doesn't always do exactly what you would expect it to. So I like to be more explicit, but it's just something to know that this idea of truthy and falsy does come up in a lot of contexts in a lot of places that you would expect it to explicitly want a Boolean. It's actually just going to treat any value as a Boolean. So what we've been looking at so far in this course is how to use JavaScript sort of in a vacuum. We're using JavaScript on its own, and we're actually running it through Node.js. However, oftentimes with JavaScript, we are using it in the browser. We are using it to add functionality to our websites. So that's what we're going to be focusing on next. So what we've seen so far is sort of the core of the actual JavaScript language. And now we'll see a bunch of features given to us by the browser when we actually use JavaScript within the browser so that we can interact with our websites. So here we have an HTML file. I also have this JavaScript file that just logs out hello world, and I have some CSS styles. And this is creating this website over here. And I'm actually running this just by right-clicking and using the live server plugin. So just open with live server, and this will open it in the browser. In this case, this is Google Chrome. So in our HTML, we have this script tag. And I'm not going to be going too in-depth on this HTML because at the end of the day, this is a JavaScript course, not an HTML course. But the script tag in HTML is how we actually add our JavaScript to the HTML. So it's going to be a standard tag that's going to go inside of the head. So it's not a self-closing tag like the link. So the link is how we add CSS, and it is self-closing, meaning we don't have a closing tag like this, but with a script, it is not self-closing. And there are a few different ways to actually use script tags, but the most common in modern HTML and JavaScript is to use this type equals module, and then to add a source, which is going to be the path to the file. So that is our script.js file right here. And all this is going to do is type equals module is actually going to defer the script. So it's going to not actually run this script until it's done parsing the rest of this HTML, so parsing the body. And it's also going to put it in strict mode, which we'll discuss more later. And as the name suggests, it also makes it a module, which essentially just allows us to have more JavaScript files and import and export between them. And then, of course, the source is where the code actually comes from. Now you can, instead of having a source, write code directly inside of a script tag. So there could be some code here, but most of the time we don't actually do this, and instead we use the source, so the src attribute. And then in this HTML, all we have is an h1 and a paragraph, and this unordered list with 3 list items. Now, don't worry too much about this HTML. Again, this is a JavaScript course, not an HTML course. This is just an example for the demo. And then the CSS, again, we don't need to worry about. It's just here to make things look a little bit cleaner. And then we have our script. You might be saying, okay, so if this script is running in the browser, how do we actually see this output? And the way we can do that is by coming over here and right-clicking and clicking inspect. So this is going to bring up this inspector. So here you can see that same HTML and you can inspect individual elements, but you can also go to the console. And this is where we're going to have that output. So we can see we logged out hello world, and that is right here. And we can actually also write code here if we wanted to. Of course, doing so is just sort of a place to test things. When we want our final code, we're going to, of course, put that in our script file. But for example, I could do something like 5 times 2 here, and you'll see it'll log out 10. So this is just sort of a place that we can write some test code. Additionally, you'll notice that next to hello world, it shows where that came from. So it came from script.js line 1. So if I open this up, you'll see we can actually see where exactly this came from. So we have our console log hello world, and this is this exact script right here. So from our console, if you're ever curious where some log is coming from, you can come over here and actually see that original code right here in the inspector. Now, we're not going to go through all of the features of the developer tools right now, but as you do more development work for the web, you should be getting more familiar with these tools over time, as you will be using them a lot for debugging your code. Next up, I want to look at how we can actually select elements from our HTML using JavaScript. So the whole purpose of using JavaScript in our web development is typically to add some functionality to the HTML. So to say something like, hey, when the user clicks on this element, we want this thing to happen. And to be able to do anything like that, we first of all need to be able to actually find elements from the DOM. And the DOM is the document object model. So here is our HTML again. And internally within the browser, we can think of this as sort of a tree structure. So at the very top, we have the entire HTML, and it has two children. It has the head and it has the body. And the body, of course, is where everything we actually see is. And then within the body, we have more elements. So we have this heading and this paragraph, and we have this unordered list. So these are all children of the body. And then this unordered list has 3 children itself. So it has 3 list items. So this is sort of the way we think about the HTML when we use it from JavaScript. But okay, if we want to select some elements, so say we want to select this list item, there are a few different ways we can do it. One of the most basic is to give it an ID. So let's say ID, and I'll just call it my item. And what I'm going to do now is to come to our script. So this is in the HTML, we're giving it this ID attribute. And in the script, the way we can get this element now is to say document.getElement by ID. And this is going to take in as a string that ID. So we called it my item. So we can say my dash item. And this is going to return to us that element. So let's say const el for element. And I'm just going to log that out. So we can say console.log our element. And if I run this, you'll see now in the console here in the browser, we are logging out this list item. So here is our list item, and it has item 1 as the content. However, getElementById is not the only way to get some element from the HTML. So coming back to the HTML, what if we didn't even have this ID? How do we get it now? Well, there's actually a few different options. So one is to use something known as query selector. So we're going to say instead, element is document.querySelector, and we're going to pass in some CSS query. So if you're familiar with CSS, you know there's a lot of ways we can select things using CSS. So for example, if we just want to get the list items, we do li. So that is the actual tag that we have here. And now I'm going to come back to the script. We can run this, and you'll see again, we have this list item, and it is item 1. But you might be noticing we have 3 different list items. So what exactly is happening with query selector? Well, it's selecting the first thing that matches. So the first list item is this one. But okay, what if we wanted, say, this one? How do we get that? Well, we could add an ID to it, but another option is instead of query selector, we can use query selector all. And what this is going to do is it's going to return to us a list of elements that actually match this selector. So in this case, all of the list items. And it's worth noting that this works sort of similar to an array, but it is slightly different. So it's something called a node list, but for the most part, it's going to work very similar to an array. So let's say this is elements, and let's log out our elements, run this, and you can see we get this node list, which looks very similar to an array with 3 items. We can open this up, and you can see we have list item 1, list item 2, and list item 3. So really they're 0-based indexing, so 0, 1, and 2. And we can open up any of these, say the middle one, and you can see it's going to have a bunch of properties, but this represents this list item here. And if we wanted to, we could do console.log elements at, say, 1, and now you'll have just this one list item, so that middle one here. And now finally, similar to IDs, we might also want to select elements by classes. So an ID is something in HTML that we can add to one element, but sometimes we also have a class. So let's say class equals my item. And the difference between a class and ID is primarily that you can add a class to multiple elements. So let's come down here and say maybe we have 2 of this my item class. There's a few ways to select this. So one, we could come in here and say query selector all. And again, with query selector, we use that CSS selector syntax. So for a class, it's going to be the dot and then the name of the class, which in this case is my dash item. And now I'll come down here and log out all of the elements we select. And you can see we get a node list with the 2 items in it. So just the 2 that have that class. Now, in addition to query selector all, if we want to get elements by these class names, another option is to say document.getElements by class name. And then we don't need the dot anymore because it's no longer CSS syntax. Now it's just passing in the class name. We can run this and you can see we get this HTML collection, which has the 2 elements in it. And for the most part, this is going to work pretty much the same way as what we had with query selector all, but now using this get elements by class name function. And all of these are perfectly fine ways to select items. That said, most of the time, what I find myself doing is if there's an ID, I use get element by ID, but for pretty much everything else, I just use query selector or query selector all if I need multiple items. So I don't actually find myself using get elements by class name very often, but it's worth knowing that it does exist as well. Next, we're going to be looking at how we can actually modify our HTML using JavaScript. So here is very similar HTML to what we already looked at, but now we have an ordered list instead of an unordered list with 3 list items in it. And let's say we want to change some of these list items. Well, we can come over to JavaScript if we want to do this in a programmatic way. And first of all, we've selected this list item and we're logging it out. So we can see that is the first list item here. There's actually a lot of ways that we can edit the HTML using JavaScript. So first of all, we could use this property that is going to be the text content. So if we do console log li.textContent, we'll see that is actually this text of item 1. So if I came up here and said li.textContent equals and set it equal to something else, so maybe we just put hello there, and then we run this, you'll see now the text content of this first list item is hello there. So it actually edits the HTML. So this is changed. And similar to text content, we also have another property called inner HTML. So that is inner HTML like this. And you can see we still get hello there. So now you might be saying, well, what is the difference between inner HTML, and I'll log this out as well, and the text content? And the easiest way to see this is instead of selecting the li, let's select the entire ordered list. So let's say we have our ordered list, and I'll comment this out for a moment, and let's log out ordered list.innerHTML. And you can see it's actually the HTML code, whereas ordered list.textContent is just the actual text. So the difference is inner HTML is actually editing the HTML, whereas text content is editing just the text content. So let's put this back to our li for a moment. And with our inner HTML, if we did something like hello there and we stuck a strong tag around the word there, well, this is actually going to add that strong tag here. So we actually bolded this text. Now, most of the time I would recommend against sort of inlining HTML code in strings like this, just because it can lead to a lot of mistakes because we don't get any syntax highlighting here. Also, if the string comes from some user input, it actually can create some vulnerabilities because that means the user can just input whatever HTML they want. And that potentially could be a problem if that's being stored on some server and used between different users. So just to be careful, most of the time, we don't want to use inner HTML. And if we're just setting text content, we'll want to use the text content. And you'll see if I do this, we actually just end up adding this entire string here. So it's not going to interpret this as HTML code. It's just going to add that as a string. That said, there's one interesting use case of inner HTML. So let's go back to the ordered list. And then let's, instead of setting the text content, let's go ordered list.inner HTML. And I'm just going to set it equal to an empty string. And what this is actually going to do is it's just going to delete all of the children. So we can see that entire list is gone. If I go to the elements, and let's make this a bit bigger, you'll see we still have the ordered list, but we set the inner HTML to be an empty string. So it just deleted all of the children. So that can be a sort of useful way to just delete the children. But other than that, I would usually avoid inner HTML. But okay, let's put this back and come back over here and undo all of this. What I want to show now is that we can actually do a lot of other things to our list item. So for example, one thing we can do is we can set whatever values we want on it. So real quick, I'll save this just to get that back. And one thing we could do is say we want to have a value attribute. And the value of a list item is actually what this number is going to be. So if, say, I set this equal to 5, you'll see now we're actually starting our list at 5 instead of 1. Another way to do this is to do it in a more functional way. So there's actually a set attribute function. It's going to take in the name of the attribute and the value, in this case 5, and that's going to do the same thing as well. We can also use JavaScript to change styles. So if we want to do something with the style, we can do .style and then whatever the CSS property name is. So for example, we can set the color to be red, and this is going to change our text color to be red. Or if, say, we wanted to change the background color, we can say background color like this, and now the background color is red. You'll notice this is camel cased, even though in CSS it uses dash naming, so it becomes camel case in JavaScript. And this can be any CSS value. So for example, I could say this is going to be 00FF00, which should be green, and it's going to set that background color to be green. We can also add and remove CSS classes, and the easiest way to do this is to use the class list property of the element. And this is going to have an add and remove method. So for example, we could say .add, and let's just say we have some green class, and I'm going to now come to our CSS, come up here, and let's just add a green class. So we can say we have this green class that sets the color to be green. Save this, and now you can see we have green text here because we added this class. And you could do this multiple times, so it's not going to override classes. So let's say this has a blue background, so maybe we have some class like this. Come here, say we have a blue background class, and we'll do a background color of blue. Save this. Now you can see we have this blue background color. Then there's also a remove function. So if I came down here and say removed blue background, it will now remove it. So essentially anything you can do in HTML and CSS, you can actually change using JavaScript when you select some element. That said, anything that's static, so just something that should exist from the time the page initially loads, you should still do in HTML and CSS. But then whenever we have something that we actually want to change based on something the user does or something maybe that happens over time, we can do that using JavaScript. So we're going to use JavaScript to add functionality, and sometimes that functionality will involve actually changing the HTML or CSS programmatically. Now that we've seen how to modify elements, I want to look at how we can just create a brand new element. So we have the same HTML here. Let's say in our script, we need to add some element to the page. How exactly can we do this? Well, there's a few ways. We've seen that we can use inner HTML. So for example, we could say document.body, which just gets the entire body tag. And we could do something like inner HTML plus equals because it is a string, and we could add something to it. So we could do maybe a paragraph, hello, and then close the paragraph. And we'd see that we do now have this hello text at the end. But doing this with strings like this is just very clunky and sort of bug prone. So this isn't usually how I would recommend doing it. Instead, I would do it using functions. So what we can do is we can say document.createElement, and then we want to pass in what type of tag we want. In this case, let's create a paragraph, so the p tag. I'm going to save this in some variables. So let's say const paragraph is going to be equal to our call to document.createElement. And then we can use this paragraph just like we've used other elements. So for example, I could say paragraph.textContent is going to be equal to hello. And then I need to actually add it to the page. So if I save this right now, there's no text here because we haven't actually added this to the page in any way. So what we can do is we can say document.body.append, and we're going to append to it our paragraph. So essentially we are passing in the element we created with createElement into the append method of whatever node we want to append it to, and we can run this and you can see we get hello. Now it's worth noting that in addition to append, we also have an append child method, which for the most part is going to do the same thing. So we still end up with this paragraph. If I go to elements here, we can see we have this paragraph of hello. So we're going to get basically the same thing regardless of if we use append or append child. But there's two primary ways they differ. So for example, first of all, we could pass just a string here. So let's say just the string of hello, this is a string. And let's run this and you can see we get hello, this is a string. You'll notice the sort of styling of this text changed. And the reason for that is that it did not add a paragraph. This is just the string we put here. So just added the string to the HTML. However, with append child, this is actually not going to work. So append child requires that you pass in an actual element, whereas append is going to let you just append a string if that is what you want. But let's go back to append with our paragraph like this. And we can see we have our paragraph back. And now the other difference is that append is going to allow you to do it multiple times at once. So let's say we have another paragraph. So let's say paragraph 2 and just hello2 and paragraph 2 here. And we could actually add a comma separated list. So we can add another argument for paragraph 2, run this, and you can see we now have hello and hello2. Whereas if we did append child, this does not allow this. So append child only allows you to append one element at a time, whereas append is going to allow you to append as many as you want. Lastly, I did also want to show that you can append to other places than just the body. So let's go back to just the one paragraph. But instead of a paragraph, let's actually create a list item. So let's say we have a list item, and we will create an element of list item, and we'll do li, and let's just use this same text here. But what I want to do is instead of adding this paragraph to the body, we're going to add the list item into our ordered list. So let's say document.query selector, and we're going to select our ordered list, and then we're going to append to it. So now I can run this, and you can see we now have a fourth list item with this text of hello. So essentially we created a list item, we set the text, we found the ordered list, and we added that list item to that ordered list. And we can see if we come into the ordered list here, here is that list item that we added with the text of hello. Now I've seen how to modify elements and how to add brand new elements, but now let's see how to remove elements from the page. So let's say we have this paragraph and we want to remove it in our JavaScript programmatically. How can we do that? Well, first of all, we probably need to select the paragraph. So let's say const paragraph is going to be equal to document.query selector, and we are going to select our p tag. Let's just come down here and say console.log our paragraph. And you can see now in the console, we get this paragraph here. So how do we actually remove it? Well, there's actually a very simple way to do this. We can simply say paragraph.remove, call this function, and you can see it is now gone. Now, interestingly enough, it does not delete the paragraph. We still have this. It's still in this variable, so it still exists. So therefore, we can still actually log it out down here, and we could even add it back to the page. So I could do something like document.body.append, and I could append that paragraph. And now you can see we've actually added the paragraph down to the bottom of the page. So we've essentially removed it from this top section and moved it down to the bottom. And for the most part, if you need to remove an element using JavaScript, the way to do it is probably with the remove method. However, for a long time, this actually wasn't an option. So I do want to show you what we had to do before remove existed, just because you might still see this out there in the wild. So instead of paragraph.remove, before we had this method, what we had to do was go to the parent element, which in this case is just the body. But if we didn't know that, we could go to .parent node, and then we can go from the parent and say remove child. So this method just existed before remove. So we're going to remove a child from the parent, and that child is going to be our paragraph. We can run this, and you can see it does remove it. So essentially what we've done is we've selected the paragraph, we've gone to its parent in the DOM, which is going to be the body in this case. And then we say, hey, from that parent, I want to remove one of the children from the page, and that child I want to remove is this one here, which happens to be that same paragraph. So it removes it from the page, and then we still can log it out because we do still have access to it. So this does essentially the same thing as that remove method, but it's just sort of a more convoluted way to do it. And again, I would not recommend actually doing this anymore, but this is the way we used to do things, and it is something that you might see out there, so I did think it was important to still show. Next, I want to look into something known as event-driven programming, which is essentially how we can write code that doesn't just run initially, it runs in response to some event. And really, this is super powerful because as we're building websites, we don't want to just do a bunch of stuff when the page loads. We want to do things in response to the user taking some action. For example, here I have this button and it says click me. And when the user clicks on it, we want to do something, right? Maybe we want to add another list item. So how can we do that? Well, let's come over to our JavaScript. And first of all, let's select the button. So let's say const button is going to be equal to document.query selector. And we can select it like this. And now if we want to listen to some event that happens with this button, for example, clicking on it, what we can do is we can say button.add event listener. So this is a method that's going to take in, first of all, a type of event. So for example, click is going to be the most common event type. And then we add a comma for the second argument. And this is going to be a callback function that is going to run whenever this element is clicked on. So let's say we have a callback function like this, and we could do something like just console.log clicked. And now let's save this, come over here, and when I click on click me, you can see we log out clicked. And I can do this as many times as I want, and it will keep logging out clicked. Additionally, if we want some extra information about what just happened, this actually can also take in a parameter that is going to be the event. So instead of logging out clicked, let's log out this event, which is going to be an object. So if I click me, you can see we have this pointer event, and it's going to have a bunch of different information about what happened when we clicked. So for example, where was the mouse? Were we holding down the shift key? All of these things that could be important we can have in this event if we need it. But okay, let's come back here and let's do what we said we wanted to do. We wanted to add a list item. So we're not going to need this event right now. And let's come into here and say const li is going to be equal to document.create element. And let's create a list item. We can add some text content to it. So let's say li.textContent is going to be equal to, in this case, let's just say item 4, and then we need to append it to the page. So let's say document.querySelector. Let's select the ordered list, and then we want to append our li. So let's save this, come over here, and when I click me, you can see we add item 4. Now, of course, all of them are going to say item 4 because we've hard-coded in this value, but if we really wanted to, we could do even more DOM manipulation to figure out what number this currently is. So for example, let's actually save this ordered list. So I'm going to call this OL, and we can say const OL is going to be equal to the ordered list. And how do we figure out what item this is? Well, it's going to be the number of children that the OL has. So we can say const list item num is going to be equal to our OL.children, so figure out how many children it actually has, .length. So this is going to get the number of children we have, but of course we want the new one to be 1 higher. So let's add 1 to it, and let's come over here and make this a template literal, so we can replace this hard-coded 4 with that value. So list item num, we can save this, and now when I click this, we'll add item 4, click again, we add item 5, and this will keep working. And of course, there are a ton of different events. We can't go through all of the different event types in this video, but I do want to show a few more that are pretty common, starting with what happens when we press something on the keyboard. How do we listen to that? Well, to do this, let's come to the window, which is just our global object. It's available everywhere. We're going to add an event listener to it, and we can listen to either key down or key up. So key down is when you press a key down, and key up is when you release it. So let's say key down, and we're going to have the event, and we'll open up this callback function. Let's just say console.log our event. And we can save this. And you can see we still have the click event from up here, but now if I press a key, so for example, I'll press the A key, you'll see we logged out this keyboard event, and you can see what key we pressed, as well as a bunch of other information. Now, if say I press the space bar, you'll see we have the space key. So the key is actually just a space, and the code is going to be space. If say I press the L key, we'll now have that key here. So any key I press, including keys that aren't just letters. So for example, I just pressed escape. You can see escape here. So any key I press will be logged out. And lastly, one other event that's fairly common that I wanted to show was scrolling. So let's add this to the window as well. So let's say window.add event listener, and this will be the scroll event. And again, I'll just log out the event. So let's say console.log our event. And then we can save this, come over here, and there's actually nowhere to scroll right now, so I will add a few items. So we have a scroll bar, and when I scroll, you'll see we get this event, and if I scroll a bunch, it will keep firing those events, and you'll see we log out this event that has some information about the scroll we just did. Lastly, I wanted to mention that we can also remove events, and the only way to remove an event is to not use this inline callback like this, but to instead give it a name. So what I'm going to do is copy this, and let's call this onClick. Let's come up here and say function, and I'll paste this without the arrow function. So this is going to be our onClick function. And now to remove onClick, we do the same thing, but with remove event listener. So for example, let's say I want to remove it whenever we press the escape key. So what I'm going to do is come over here, press the escape key, and you can see the code is escape. So what we're going to do is check in here if we have escape. So we're going to say if event.code is strictly equal to escape. So if we pressed escape, what I want to do is now remove the onClick handler. So I'm going to copy this code, but change it from add event listener to remove event listener, but with the exact same parameters. So now when we press the escape key down, it's going to remove this event listener, not allowing us to click the button anymore. So I'm going to save this, come back over here, click on this, and we can see it works. But now I'm going to press the escape key. And now because of that, this will no longer work. There's no more event listener on this click me button because I removed it right here. So when we write front-end JavaScript, a huge portion of the code we write is going to be event-driven programming, meaning we are going to run some functions, so to run our code in response to some event, usually some event triggered by the user, such as clicking on something. Next, I want to look at how we can throw errors and how we can handle those errors in our code using try and catch. So here we have this function to calculate the area of a rectangle given a width and a height. It just returns width times height. And we have a width and a height of 10 and 5. You can imagine these are coming from some user input in some way. Then we're logging out calc rectangle area with our width and height, and you can see we get 50. But what would happen if, say, we have no height? Because maybe the user just hasn't given it to us yet. Well, now if we run this, we get NaN for not a number because we did 10 times undefined. And maybe this is fine, but maybe what we want is to somehow from this function signal to whoever called the function like, hey, something went wrong here. And the way we can do this is by throwing an error. So I'm going to come up here. I'm going to add an if statement. So let's say if the width is equal to null or undefined, or the height is equal to null or undefined, and we are missing vertical bar here. So if either of these is true, then what I want to do is throw an error. So we can say throw. So we're going to use the throw keyword. And you can actually throw any value. So for example, I could say throw -1, I could say throw and then some string like error. But typically what we do is we throw a new error. So this is the syntax to create a new error object. And this is going to take in some value. So usually we have a string here, something like width and height are required. And now if I run this, you'll see we actually throw an error. So we see error, width, and height are required down here in the console. So we are not able to run this function without a height. But if, say, we had a 5 here, we would now get 50. So instead of ever getting this NaN value, instead, if we don't have a width or a height, we are simply going to throw an error. But now down here where we actually call the function, we might want to not just have this error sort of propagate up into our console. Maybe we want to do something with this error. So if we are in an error state, do something else. So the way we can do this is by using a try catch. So I'm going to say try and open up a block. So we just say the try keyword and open up curly braces, and we put any code that we want to run inside of this try. So this says run this code, but if there's an error, that's fine. Just end that part of the code here. So I'm going to now put a catch here. And the catch does have parentheses because it can take in the error. So we can say we have the error here. And then in the catch, we could do something like const.log caught error. And now let's run this and you can see we have caught error. But if say height is equal to 5, now we once again have 50. So essentially it's going to run this code or any code inside of this block. So we could have multiple lines here. So maybe we could do console.log hello. And you'll see this will run as well. And it's just going to run this code inside of the try block until it gets to an error. And if it gets to an error, it's going to catch that error, meaning it's just going to move down into the catch block, and it's going to run whatever code we have here. And we could also actually log out this error object. So we can see if we do console.log our error, and let's put this back to not having a height, you'll see we log out the actual error. So this is the error object that we threw here. And you'll also notice we never logged out hello, so that code actually never runs. So once we get a single error inside of the try block, the rest of the code does not run. However, if instead, say we move this up here, well, now we end up with hello, and then we catch the error and we log it out. So this ran without any error, but then this threw an error, so that's where it actually stops. So any code after the error inside of the try does not run, but the code before it does run. And if we wanted to inside of catch, instead of logging out all of this, the error is actually going to have a message on it. So this is going to be the actual string that we passed in. So if we wanted to just log out the error message, we can do it like that. Now, along with try and catch, we also have one other block we can add. We don't tend to use these too often, but sometimes you'll see it. And that is a finally block. So let's say console.log end. And what this does is it runs this code no matter what. So this is going to run regardless of if we catch an error. So you'll see we have end here, but also if we had height as 5, we will still get to the end. So essentially all try, catch, and finally do is try is going to run this code until it finds an error. And if there's an error, it's going to run the code in the catch and it'll pass in the error to us so that we can actually use it. And then the finally is going to run at the end, regardless of if it caught an error or not. And there are some functions built into JavaScript that do throw errors, but most often we will get an error when we actually throw one ourselves. So something like this, throw new error, and then we pass in whatever we want to be that error message. Or if you wanted to, you could technically just throw whatever we want. So if I said throw 100 here, and here just const.log our error, and then make us actually get into the error, you'll see we log out 100. So this error actually becomes whatever value we throw, regardless of if it is that error object or not. And now where you actually use errors as well as try and catch is something that's a bit up for debate. There can actually be some negative performance aspects of using try catch and throwing errors, so some people try to avoid them as much as possible. And then there's also sort of this question of where is it semantically appropriate compared to, say, just having an if check and returning some different value if, in this case, for instance, we have no width or no height. So in some code bases, you'll see them used sort of like this in places like just checking to make sure that the parameters are actually there and what we expect. But in other code bases, they might say, hey, just use throwing errors for sort of extreme cases where something very unexpected happens. So maybe you try to make some request to like a database or some network request somewhere, and that fails for some reason, maybe like lost internet. In those cases, maybe you throw an error, but then in places where there's just like a missing value, rather than throwing an error, you could just return something else. And again, this is one of those things that just comes down to personal preference, and one of those things that you sort of get a feel for over time when it's going to be appropriate to throw errors versus when it might not be the best choice. Next, I want to discuss something known as strict mode, which is the opposite of what we sometimes call sloppy mode or unstrict mode, which is the default mode of JavaScript. And all strict mode does is it makes JavaScript slightly stricter. So some mistakes in non-strict mode are just going to be sort of silently ignored, whereas in strict mode, it's going to explicitly throw errors. So for example, here we say num is equal to 10 and we log out the number and you see we get 10. But you might be saying, what is this? What is num? We don't have let or const or even var here. We just have num. Why is this even working? And this is working because we're not in strict mode. So it just sort of tries to figure it out. But if we want to go to strict mode, there's actually a few ways to do it. So one is simply if we're using modules, which is what you'll actually be using in almost every modern project. So most of the time we're sort of just default into strict mode in modern times. But if you're not, like I am right here, well, then you can actually just add the string of use strict to the top of your code. So we're not actually putting this in some variable or anything like that. We're just typing out this string of use strict. Now you'll see if I run this, we actually get an error. So reference error num is not defined. And again, if I comment out this code, we just get 10. And then if I put it back, we get that reference error. So just adding this to the top is going to put the entire file in strict mode. It's going to make it slightly stricter for things like this. Another example that you see sometimes is, say you have a function, let's make this an add function, and we're going to add two values. So I'm going to do a plus a, and let's return this. And then we can say console.log a call to add of, say, 5 and 10. Now let's clean this up a bit. And you might be saying, what is this? A and A, what does this even do? We have two of the same parameter name. And if this is not in strict mode, you'll see we get 20. So it just ends up using the second one and we do 10 plus 10. But that's not what we wanted. We wanted to notice that, oh, we shouldn't have the same parameter name twice. If this is in strict mode, you'll see we actually throw this error, duplicate parameter name not allowed in this context. And that might tell me, okay, I need to fix this and make it A and B, and now we would get 15. And with functions, you can also make strict mode be just for that function. So I could take this and say, put it inside of the function at the top of the function like this. And if I put this back to A and A, we would once again throw that error. But now if I put this to A and B again, and then we had some error after the fact, so say down here, I just say X equals 10. Well, this is still allowed because this is not in strict mode. This code is in strict mode, but this is not, so this does not actually throw an error. But of course, if I move this back to the top, now again, we get an error because now the entire file is in strict mode. And there's a lot of other very small changes that strict mode makes, But for the most part, just know that your code's probably always going to be running in strict mode. And if it's not, you probably want it to be running in strict mode, but it's also probably not going to make any difference if you're writing good, clean code. It might just help you find some little typos or small mistakes like accidentally using the same parameter name 2 times or forgetting the let keyword. Next, we're going to talk about something known as automatic semicolon insertion. So something you might notice here and something you might have noticed just playing with JavaScript is that I have no semicolons here, and this is still working. So semicolons in JavaScript are sort of optional. So they're not technically optional. So what it actually is that JavaScript can figure out how to automatically add them. So we call this automatic semicolon insertion. So there essentially are semicolons here. They're just being automatically inserted for us to allow this code to properly run. So sometimes you'll see that a lot of people just don't use semicolons at all in JavaScript. And for the most part, that's perfectly okay. However, personally, I do still prefer to use them. And the reason for this is partially just because I feel like it's sort of part of the language and it's just the way that I'm used to using it, to be honest. But there's also something to be said for the fact that allowing it to automatically do this can create some bugs. So let's say we didn't have these semicolons. And then after this code, we also had some array. So let's say we had 1, 2, 3, and we're going to do a for each loop on this 1, 2, 3, and say for each number, we just want to log out that number. So essentially, we're just logging out the numbers 1 through 3. But this is actually no longer going to work. So if I run this, you'll see cannot read properties of undefined. So what's happening here? Well, JavaScript has to figure out where to put the semicolons. You might think, okay, it's just going to put them at the end of every line, just like this. And that would work. So that's clearly not what it's doing. And it's not what it's doing because we've seen before that JavaScript doesn't really care about whitespace, right? So it can't just say, oh, lines end at the end of the line. So it has to try to figure out where the code actually ends. So this code is essentially equivalent to this code. And what does this look like? It looks like we have some value and we're trying to do like an array or object access here. So it's trying to say get 10 and then get like this array access at the 10 value, which is just not valid. It's not going to work. So we end up with undefined, and then we try to do undefined.for each, which of course does not work. So instead, we need to actually manually put the semicolon here, and then this would actually work. So we actually don't need the other semicolons, but I would argue we should just put them all there. Now, the sort of opposing opinion here is that this is sort of odd code. This is very contrived code. I had to actually put effort in to find an example where automatic semicolon insertion would actually fail. This is not something that comes up often, and you could write hundreds of thousands of lines of JavaScript without ever running into an issue with automatic semicolon insertion. But personally, I just don't think it's worth it. I think it just makes sense to be explicit and say, hey, this is the end of this line of code, and add these semicolons manually. Also, one small note with automatic semicolon insertion is that it's just for the end of statements. It's not for other types of semicolons. So for example, if we have some for loop, so let's say let I equal 0, while I is less than 5, and I plus plus, and then let's say we want to just console.log out I, these semicolons here are actually necessary. So this semicolon inside is not. If I remove it, nothing is going to change. But if I was to remove these semicolons, well, now JavaScript doesn't really know where one of these ends and the next begins. So these semicolons inside of the for loop are actually necessary. If I try to run this, you'll see I just get a syntax error. So we do need these semicolons here, but we don't need these semicolon down here. But again, my personal preference tends to be to just always use semicolons. All right, so that's going to do it for this beginner JavaScript course. Of course, there is more that we can cover on JavaScript. So if you want to see another sort of follow-up course to this one, do let me know. And of course, subscribe for future content. Otherwise, I'll see you all in the next video.